Hello there. If you are watching this on YouTube and I'm not live, because I am live right now, be sure to check the description so you can skip ahead to the main content. In the meantime, we're going to hang out in the waiting room, so I'll see you soon. Hello, friends. Oh, didn't mean to do that. Welcome to Coding Garden. Welcome to Web Security Wednesdays, where we will be today focusing on cross-site scripting. So if you're new to security on the web and stuff like that, we'll explain what cross-site scripting is, and then we're going to try to hack applications that are vulnerable to cross-site security, vulnerable to cross-site scripting. Specifically, we're going to be using this thing called OWASP Juice Shop. So OWASP is the Open Web Application Security Project. They have a ton of resources on security on the web, and you can learn more about security stuff, and like you can join your local meetup and foundation and all that good stuff. But they are the stewards of this project, which is the most modern and sophisticated insecure web application, in that it's built with more modern web tech. It's built with Angular. It has a node.js backend, but it's vulnerable to a lot of things. And we specifically are going to be focusing on the cross-site scripting challenges that are within it, but there are a ton of challenges within. And the first challenge is actually finding the scoreboard on the website. But once you find the scoreboard, it actually will show you all of the various things that are vulnerable within the application, and you can start to try and, I'm forgetting the word, try and, when you take advantage of a vulnerability, what are you doing? What word am I missing? Exploit. Try and exploit. I don't know why I couldn't think of the word exploit. Exploit. You can attempt to exploit all of these. And what's up, Clarkio? Yeah, welcome in. I saw your resub. Thank you for the 43 months. And Clarkio, are you still at Snick or Sneak? Because they have a really good article on cross-site scripting. I didn't read the whole thing yet, but it's really good. But actually, they need dark mode on their website. Sneak. Awesome. But yeah, this is what we're going to be doing. We're going to spin this up locally. If you go to their repo, and actually I'll need to update the today command. But if you go to their repo, they show you how to get this thing set up locally. And what's cool about OWASP Juice Shop is that you can just run it on your machine. A lot of the other stuff online for learning to hack, you're kind of using someone else's hosted server or using a VPN like on Hack the Box to get into a network that has a vulnerable web server, but this you just start up locally and you can just try to hack it locally. So you don't have to worry about connecting to any remote machines or anything like that. And their documentation shows you how to get set up. We're specifically just going to use the Docker container. It's super easy. You spin it up and then we can start hacking. But again, I'm actually like 30 minutes early, so we're going to take a step back, say hello, welcome everybody in. We'll explain what cross-site scripting is. We'll also get warmed up with this cross-site scripting game that was created by Google a few years back. Yeah, we'll talk about it all, but welcome in everyone. It's good to see you. Oh yeah, look, for some reason the commands on YouTube were taking a while before they showed up, but someone asked about the keyboard that I'm using. If you check out coding.garden/gear, it has all the stuff I'm using. And this is the keyboard that I use right now, which last I saw had a really good deal. Yeah, the deal is gone. There was like a few days where this thing was only $35, but it's back to 60. Cool. And thanks, Heck. Yeah. And this is the other thing. You might have already learned this if you didn't know. XSS is a short how we abbreviate cross-site scripting. And you probably have heard of XSS, or you probably have heard of cross-site scripting, but we're going to talk about what it is, and we're going to actually exploit it. We're going to get our code running on someone else's website. Cool. But first up, let's say hello to everyone. And also, I'll show you how my overlays work, because I know there's a lot of new people here. And so you can see some people in the chat have their their country flag set. They have their team. And you too can do all of those things. So I'll show you how to do that after I say hello. So if you would like me to say hello to you, you can say any of these things. So send a message that matches this regular expression, and I will acknowledge you. And it must match this regular expression exactly. You'll notice there's a word boundary here and on the end. So if you say hello, but it's attached to some other word, that's not going to work. Or if you spell hello wrong, that also won't work. But let's do it. Let's go back in time to 16 minutes ago when Vinicius Cerqueira Bonifacio, I don't know if I said that right, but they were the first to say hello. Welcome in. Hello. What's up, Paul Thomas and Riot Sia and Abhishek. Hello, Friniz and 8-Bits. What's up, Henrique and Vikas? How's it going? There's 2 messages in the chat. That's weird. And Taquito, thank you for the prime. Appreciate you. Tech Turner, how's it going? What's up, Jack Scott? And Amitabh and Monir. Yeah, there's two YouTube chats for everything. This isn't good. This isn't good at all. Did that fix it? Yeah, okay. I think just refreshing my overlay fixed it. Oof. Prawin, how's it going? What's up, Mark and Stas? Good to see you. And David, hello. What's up, Jonah and Mark? And Itakito and Doof and Keen Cyber. What's up, Sicko and Jonah Joe and Stony and America 2050 and Jop. How's it going? What's up, Arcouldn't? And Matt Cobalt and Drop Mania. It's been a long time. Welcome in. What's up, Shaful and Prashant and Demerka and Eddie? Heck, how's it going? Z1s or Zins and Speedstrat. What's up? What's up, Bash RC and Comic Crazed and Nuve and Codeine Garden. That's a different kind of garden. Welcome to the stream. What's up, Demetrio and Milan Bhakta, Flo, Secret Val. Good to see you. What's up, Dysavine, Nick Thiel, Curried Lambda, Yazana, Ex-Opportunist, Mr. Gainframe, and Ina Muir. Ina Muirman. And Funsak. Welcome in. A lot of new names in the chat. I appreciate you all being here. I actually know who this is, and it's really funny. But yeah, so many new names in the chat. Welcome to the Coding Garden. Glad to have you. Einam Uriman. Einam Uriman? What? Are you trying to get me to say something weird? I know that's that person's name. I don't know. Let me show you how to customize the overlay. So, for instance, you can see Funsak has the Nepal flag set next to their name. And Eddie has the Sao Paulo flag and the Tux Linux penguin. Mr. Gainframe has the Uganda flag. America 2050 has the Argentina flag. Also, America 2050, you sent a message. Let me... Oh, but not hellos. I don't know how to search my own overlay. Here we go. As newbies, should we really worry about this, or do libraries already protect us out of the box? That's a good question to ask, and I'll point to that later. But yes, if you're using, let's say, like React or Vue or Svelte, or a lot of server-side rendered template languages, they have built-in escaping. And so a lot of times you don't necessarily have to worry about this. Where I'll show you where you do have to worry about it is, like, let's say you're in React and you decide to use dangerously set inner HTML. It's called dangerously set inner HTML for a reason, but that's when you become potentially vulnerable to cross-site scripting. And then also... there's similar mechanisms in Vue and Svelte and Angular to directly set the HTML. And then if you're just using Vanilla JS, element.inner HTML or outer HTML is another way that things can potentially be injected. But we'll talk about that. We'll talk about things you should potentially use instead. And then also, like America 2050 is asking, if you are using those libraries, technically you're safe as far as those libraries are concerned. But sometimes vulnerabilities are discovered in those libraries, and then it still is potentially possible to exploit a cross-site scripting vulnerability. Okay, let me show you how to customize the overlay. Yeah, and that's a great example. I should go ahead and start taking notes because you all are coming up with good stuff. Learn to hack. Don't I have a learn to hack repo? Learning to hack. Actually, we'll just call it XSS. Learning span. Oh, I did a stream a long time ago, probably like 2 or 3 years ago, where I got my friend on stream, who spoke Spanish, and aprendiendo. And I tried to learn Spanish. This was 4 years ago. Wow. But the thing is, so they're a native Spanish speaker, but they learned to program in English. And so we got them on stream, and then I was learning all of the Spanish terms for programming terms, and it was fun. It was fun. So yeah, that's what the learning Spanish directory is. Let me just take some notes so we don't lose this stuff, and then I'll show you how the overlays work. Are we protected if we use libraries? This was a good question that came up. And then another thing that came up was, scenarios where you might be vulnerable in a Markdown renderer. Because by the nature of it, a Markdown renderer tries to render HTML and show it onto the page. And so if that HTML you're rendering has some kind of user input in it that hasn't been sanitized, that could trigger an XSS as well. Yeah. Yeah, and so cross-site scripting isn't exactly the same thing as injection or command or SQL injection, but it shares attributes in that if you do not sanitize your user's input, then you potentially will be vulnerable to that exploit. Any alternative to dangerously set inner HTML? There actually is if we're specifically talking about React, there's a really good Markdown renderer that doesn't use dangerously set inner HTML. Okay, but we'll talk about this more in a little bit. Let's just say hello. Or not say hello. Let's show you how the overlay works. So if you want to set your team badge or your flag in the chat overlay, this message has all the info you will need for that. Specifically, we'll set our flags, though. So if I do flag followed by my country code, and you're going to want to do your 2-character country code. And so for me, that's US because I'm in the United States. And now all of my messages will have the US flag on them. However, we have states, provinces, and sometimes cities as well. So if you go to this repo, which we've been working on and maintaining, if there's a directory for your country, that means we also have either states or province flags for that country. And then if there's a directory for a state or a province, that means we also have flags for cities. So you'll notice I'll have, oh, are these new? These are newer. These aren't new. This was a year ago when I thought of things that I want to do for this library, but I haven't done yet. But you'll notice I can set mine to US/CO because CO is Colorado. And if I do that, then I get the Colorado flag. And then I can also set it to the city I live in, which is Denver. So if I do US/CO Denver, now my messages have the Denver flag on them. So you can do the same thing. If you want to see if your flag is supported, go over to this repo, go to the SVG directory, see if it exists. If it doesn't exist, you can make a PR to add like states or provinces or cities. But that's the way to go. Nice, Clarkio, you did it. I really like the Denver flag. Yeah, it's like very minimal, but it's supposed to be the like the sun rising over the mountains. Yeah, and make sure you use slashes if you're going to be choosing a state or a province. Use slashes, or it won't be able to detect it. Also, you can set your team. So there's a couple of places you can pick your icons from. If you go to the Font Awesome brand cheat sheet, it has all of these things. You can also go to simple icons. You can see the brand name and then the slug. The slug is what you're going to want to use. But if you also just go to simpleicons.org, you can get a preview of the various icons. I wonder if OWASP has an icon. They do. That's really cool. So I'm going to set my badge, my team icon, to be OWASP. And so in the chat, I can do team, followed by the name. And then there we go. I've got the OWASP logo. That's awesome. So if you scroll up in the chat, actually, and I'm not sending these. I should be sending these on YouTube too. Yeah, thank you for that. Thank you for that, Mohammed. Yeah, so the link for the flags repo will be in the messages there. So it is this link right here, this GitHub link that takes you here. What else? You can also set your pronouns. So you'll notice I have my pronouns set to he, him, his, which are my preferred ones. You can see what's available with what pronouns. And then choose from this list. Ooh, message. Nice. Niedersachsen. Niedersachsen? Where is that? Oh, it's in Germany. I see. DE. Fascinating. Do I have a repo for your chat overlay with these badges? There's a lot to unpack there, I guess. I have a repo called SproutKit. This is the repo that holds all of the code for this overlay. It's really messy. It's many years old, and it's going to be rewritten eventually, hopefully soon. I'm getting in the habit of streaming and fixing things more often. But this repo is what holds the code for this overlay, which is the same code for this OBS overlay here. And within it, there is parsing of messages and then pulling in the flags and everything else. But I'm storing that flag info in my own backend database. Yeah, so all of that's here. And then the actual way that it gets set in the backend is in the backend repo. So that is here. And then this is also really old and needs to be rewritten. I mean, obviously, just because it's old doesn't mean it needs to be rewritten, but there are other reasons why I want to rewrite this. First of all, it wasn't written with TypeScript. It's all JavaScript. I want to rewrite this with TypeScript. Also, this is using Feathers version 4. I want to use Feathers v5, which is newer. So there's a lot of reasons that I want to rewrite. And it'll mostly be a port. It won't be a direct rewrite, but yeah, I have like this command service. It's listening for commands, and then when a command comes in, like set flag or set team, it sets it in the database, which is how it's able to persist. But I'll send you these repos. Ideally, and we've talked about this in the past, ideally what I want to do is create an add-on for Franker faces so that these badges and everything else can be displayed directly in the Twitch chat. Because it is possible. Is my overlay vulnerable to XSS? That's another fun thing, is when we were building this, it was. And it still might be, but we're using a library called DOM Purify. And actually, I'll add this here. How to, yeah, something like, yeah, how do we use these two things safely? And the answer is sanitize/purify. And there's a library I use called DOM Purify. But I'm using an outdated version. Someone mentioned this. They came into my stream and they're like, they didn't tell me directly. They just started sending messages that would potentially do a cross-site scripting attack. But I was like, we're using DOM Purify, but they were like, you're using an old version of DOM Purify. So yeah, but I digress. Franker Faces is the plugin I use so that I can see better Twitch TV, 7 TV, and Franker Faces emotes, but all of these are custom add-ons. So I could create a custom add-on that actually shows your flag and your team in Twitch chat directly if you just enable that add-on. That's another idea we want to do eventually. But that way, if I do that, then people won't have to like have my custom overlay or anything, and you'll be able to see all of the flags and badges and everything directly in the chat. But yeah, if you look at the streams where I was building this overlay, people had a really fun time trying to hack it. And for a while, like there were certain vulnerabilities that weren't exact. I guess they technically were cross-site scripting, but they were people were injecting things that would do funny things. Like at one point, Stoney's in the chat. You may be able to cleverly break it by nesting certain DOM nodes. Well, that was another thing that broke it, is deeply nested nodes caused the overlay to just run really slow because of, I think it was because of the sanitization we were doing. But Stoney broke out one time. He figured out that you could send a message that would embed, I think, like a canvas or a figure or something like that. And then he made it so that it appeared outside of the chat box. So you kind of like broke out of the window. Yeah. Actually, there was I also did a stream a while back where I purposefully, I basically made a little Electron app that looked like this, but it was vulnerable to cross-site scripting and like style injection. And then I just made it full screen and left it open for the chat to try and hack for like an hour. I forget when I did that. That was years ago when I did that too. We should probably do that again sometime. That would be a fun like 24/7 stream where you just see this window and people in the chat are trying to cross-site script it, but then it just like resets every hour or something like that. Yeah. There we go. Oh, this is the clip. Let's look at the clip. Let me plug in. It could turn out very horrible. You would probably want to be running it on a virtual machine and then like screen capping that and like not running it on the machine that's actually streaming. Can we display none the top bar? Oh, he broke it. See? Oh, nice, Stony Eagle. Like I believe you might be the first one to break out of your little chat jail, and for that, you get VIP'd. Congratulations. I don't know if you could hear it. I don't know if it was loud enough, but I was like, you might be the first one to break out, and for that, you get VIP. Cool. The volume was okay. Cool. So yeah, we've had a lot of fun with it. Honestly, the videos are getting harder and harder to find on my YouTube channel. But this repo does have this document, which links to various streams where I was working on the various overlays. So this isn't all of them, but it is a good rundown of a lot of the streams where I was working on this stuff. Share your password day? Like, what's up, Greg? I've never heard of share your password day. Oh yeah, last thing. We're all over the place today, but let me show you how to set your pronouns. So you can see I have my pronouns set. You can see the list here. If you do what pronouns, and you can pick from this list, she, he, they, ko, none, they, hi, it, one, m, or yo. And then do exclamation mark pronoun, followed by one of those. So my preferred pronoun is he, him, his, so I can do he like that. And now it will display. Well, I said what the pronouns were. I didn't exactly show people how to set them. And I'm not going to show people how to set their status. That's only for the people that can read the code in my repos or have been here for a few years. But you can see some people have this scrolling message or just like various messages on their message, or various statuses on their messages. Yeah. Okay. I think that's everything I want to say. Is everyone here? Type 1 in chat if you're here and you're ready to learn about cross-site scripting. Who isn't here? Press 2 if you're not here. Nice. Also, how's my audio? This is the first time in a long time I'm actually talking into my microphone right here. Usually it's off like over here, but for various reasons I've decided to start doing this. Also look more like a streamer, right? When I have my microphone in my face. Yeah, okay, yeah. So what is audio is fire? Nice, thanks, Matt. What is oh yeah, so this, how do we prevent it? / fix it. Come on, one line of me. Somebody would have told me. Yeah, how do we prevent it? Or we fix it? Someone asked this questions. Are we protected if we use libraries? And then, yeah, scenarios where you might be vulnerable. I think apply under how do we prevent it or fix it. Cool. I haven't moved from Hack the Box. No, I mean, we just did Hack the Box last week, but the thing is, the stuff I was doing on Hack the Box last week was very different than web development, which is what I typically do on my stream. So I feel like a lot of people didn't necessarily watch or weren't as interested because it didn't have as much to do with web development and web security. We were scanning ports, taking advantage of misconfigured FTP and Telnet and Redis servers and various stuff like that, which isn't exactly web dev. Today, if you're a web developer, you should know what XSS is. You should know how to prevent it. This should be front of mind when you're building applications as a web developer. So that's why I'm focusing on this today. Can you prevent XSS with scanners? Probably. There are very likely tools. I haven't used these personally, but there are very likely tools and plugins which can analyze your source code to say, hey, you might be vulnerable to it here because you used the dangerously set inner HTML or something like that. All right, let's jump into it. I'm going to do my best to do like a little YouTube intro, extra spicy security. I like that acronym. I'm going to do a little YouTube intro so we can edit this down later. Will I ever do Flutter? Probably like on a Try Day Friday or something if people are still interested in it. Let me get my tabs ready. Cool. Wait, okay, I'm waiting. I just realized I have like this glare on my shirt. How about now? XSS is TypeScript for CSS? That'd probably be a good name. Okay, fixing the glare, I think, fixed it. And Dropmania, thank you for the Prime. All right, let's get into it. Hello, friends. Welcome to Coding Garden. Welcome to Web Security Wednesdays, where today we're going to be focusing on cross-site scripting, or also referred to as XSS. And so we're going to talk about what it is, what are the kinds of XSS you might come across, how do we prevent it and fix it, and other various questions that might come up in the Twitch chat. Also, after that, we're going to be doing some challenges to try and exploit websites that are vulnerable to cross-site scripting. So there's this game that was created by Google, which we can try out. And then we're also going to be using OWASP Juice Shop. This is a purposefully insecure web application that you can run locally that has a bunch of vulnerabilities that you can potentially exploit. And so we're going to focus on all the cross-site scripting vulnerabilities to try and exploit them in this app. We'll get it running locally, and then we'll be looking through the OWASP Juice Shop book to figure out what are the challenges that we want to do today. Now, the OWASP Juice Shop has more than just cross-site scripting. It has like command injection, SQL injection, cross-site request forgery, all kinds of various vulnerabilities that are exploitable, that are purposefully exploitable, so you can learn about them. So this is the big long list of all of them, but we're specifically going to be doing all of the cross-site scripting ones. It looks like there's like like there's at least 10, probably more than 10 cross-site scripting challenges, which we're going to do. All right. First up, what is XSS? So we already mentioned it stands for cross-site scripting. And this is a vulnerability in a website that allows an attacker to execute malicious code or their own code on someone else's website. So let's read the definition from Wikipedia and then break it down. So it's a type of security vulnerability that can be found in some web applications. XSS attacks enable attackers to inject client-side scripts. That's a good distinction to make. You're essentially injecting scripts into a web page, not into the server, but into the web page, into web pages viewed by other users. A cross-site scripting vulnerability may be used by attackers to bypass access controls, such as the same origin policy. Cool. So that's what it is. I think the best way to really show you what it is to show an example of where something might be vulnerable, and then we'll kind of like take a step back and like make a list of things. But first, we'll do it with this XSS game. So you can actually go to this URL, xss-game.appspot.com. This was created by Google to kind of teach about XSS, and also you can practice doing it. So we'll do the first challenge here where you can see where a potential injection comes from. And so we just have this this little search box here. We can input a search. It'll try to search it and then bring the page back. But this little input box here is vulnerable to cross-site scripting. If we look at the actual source code for how this page works, they're actually showing us some Python code. So it's Python code that is rendering the page. But typically, when you're trying to exploit a website that's vulnerable to cross-site scripting, you wouldn't necessarily have access to the backend server to see their source code. But we would be able to open up the DevTools and look at the actual source of this here. And essentially what's happening is whatever is typed into the search box is just reflected onto the page itself. So let's find the piece of code that does it. So right here is where we would input our search term. And then right here is where they are vulnerable to cross-site scripting. So you'll see when they render the page, they take whatever the user typed in and then render it directly right there in the page. So if I got clever and I did something like this, this image, which will break. So if you put an image onto a page, you don't specify a URL, the on error event will get triggered and will actually execute the code right here. So if I do this, look at that. We've gotten an alert box to pop up. And I guess you also know, I think right now the URL here is broken, but you'll notice that if it didn't say object, you'll see it flash for a split second. You'll see it flash, and you'll notice that actual injection gets reflected in the actual URL. So the reason that this is bad is because your average user isn't going to want to run scripts against themselves. They could just open the DevTools if they wanted to do something like that. But the reason this vulnerability is especially bad is I could take this URL, share it with anyone, and now if they go to that URL and go to this website, I'm now running JavaScript in the context of that specific user. So for example, if I had if there was like a phishing attack where I sent this link to the admin of the website, and then when they go there, they're logged in as admin, because I can run whatever script I want. Right now I'm just showing alert as an example, but I could have literally any JavaScript I want right there. I could write some code that steals things from local storage or makes requests on behalf of that user because it is running as that user. Yeah, and phishing with a PH, exactly. So this is your first example of cross-site scripting. Essentially, the developer of this website has not sanitized the user input, and it gets directly rendered on the page, making it so that scripts that were not intended to be run on the page can be run on the page. And there are different kinds of XSS. What we just showed is reflected cross-site scripting, in that it essentially is using information from the URL to then be rendered and served onto the page. There's a few good resources I have here that talk about what cross-site scripting is. The first one is from the OWASP website itself, and they talk about the different types. So a reflected attack are those where the injected script is reflected off of the web server, such as in an error message, search result, or any other response that includes some or all of the input sent to the server as part of the request. And so in this case, the server is reflecting that image that I injected back to the rendered page. So that's an example of a reflected attack. There are also stored attacks. And so this is where maybe there isn't a maybe the website doesn't work by passing in query parameters that can be exploited, but maybe there is a description for your profile. And let's say you go into your profile and you put an attempt to exploit cross-site scripting vulnerability in your description of your profile. What could happen is now that potential exploit is stored in a database. And then when someone else comes along to the website and visits your profile, if the page is not sanitizing the description, it'll potentially run that script that you have there in your description. So that's an example of a stored attack. It doesn't necessarily need the URL to inject something into the page. It's stored in a database somewhere, and then when someone visits the page, it runs that script. A good example of this is actually in this article from sneak.io. So Sneak is a tool, a bunch of tools you can use for managing security in your company and in your projects. But they have a bunch of really good articles on a lot of security topics. Specifically, they have one on cross-site scripting, and you'll see this first attack that they described, which actually was a cross-site scripting vulnerability on Twitter. And so this was an example of a stored cross-site scripting vulnerability because a user sent this tweet that gets stored on Twitter servers, and then anyone that views this tweet now runs the script that was the tweet itself. There was a specific reason, like I think it had to do with the way Twitter was parsing emojis. So it had to do with the way that Twitter was parsing emojis, because regularly, like Twitter, a huge website, would not want to be vulnerable to cross-site scripting. So if you attempted to make a tweet like this, even if you're allowed to, it's not going to be vulnerable right now. Unless you find an edge case like this, where if your message includes an emoji, for some reason it wasn't getting sanitized in the right way. So this is an example of a very big company, a very big website that were vulnerable. So the person that sent this tweet, essentially anybody that comes and views their tweet would have seen an alert on their webpage. But to make it worse is someone then saw, oh, now that they're vulnerable, now we're going to do something malicious. And they made it so that anybody that viewed their tweet would automatically retweet their tweet. And it actually brought the website down, because you can imagine the how this could just quickly grow really, really quickly to basically send so many requests to Twitter servers, where a person tweets, but the malicious code is code that will in turn retweet the current tweet. And then anybody that views that will retweet it. And then anybody that views that retweet will potentially retweet the retweet. And everyone was just retweeting the same tweet, and so it brought the site down. So this is an example of it happening in the real world, and which is why we don't want to be vulnerable to this. Yeah. Okay. So yeah, we talked about reflected. We also talked about a stored attack, and so this is an example of a stored attack. This is an example of a reflected attack because it's reflecting it in the URL there. Does the log4j vulnerability, is that considered a cross-site scripting? I don't think so, especially because log4j is like a backend technology. I don't know what the vulnerability is. I know it was in the news. Is this the one from last year? It wouldn't be cross-site scripting because it it's happening in the backend, and more than likely it's like command injection, which is a different kind of vulnerability. How does the exploit work? Yeah, inject malicious code into the logs that can be executed on the system. Yeah, so this is known as command injection, where they're injecting code that eventually will actually be run, and so you could potentially start up a process on a remote machine, or inject code and your malicious code can potentially run on the remote machine. But this is not cross-site scripting because it's happening on the server side or on some computer directly. It's not happening on a web page. But that's another kind of injection, which we'll talk about in a future episode. Shaw is asking, is clickjacking considered cross-site scripting? I don't think so. I think that's like another category, which a lot of sites just aren't vulnerable to anymore because a lot of the protections that have been added to web browsers. But clickjacking is where, let's say you have an ad that shows up on a page, and if that ad can inject code that covers up another part of the website, like let's say you're clicking something on the website, and you think you're clicking something else because you can see it, but some malicious code has actually put something on top of where you're clicking. So you click, which takes you somewhere else, or you click on something you didn't mean to click on. And it's possible you could use cross-site scripting to like inject a clickjacking attempt. But I would still distinguish it. I don't know if there's any security people in the chat. I don't know what you would say about it. So yeah. I think I missed this message right here. Man, I need to fix my chat overlay. I can't see the text here. Nothing says, in the wild, most common cross-site scripting is blind and cache-based, cache poisoning, combo vulnerabilities. Probably it's region-based info. So no, I mean, and that's a good point to bring up because that's the other one that I didn't talk about yet, which is blind cross-site scripting. So we talked about reflected, stored. The other one is blind, and that is, you have no idea if the code you're attempting to inject is going to be run somewhere. You just kind of like hope and pray. And so it's similar to stored in that you're potentially updating values that you have access to, like on your user profile or anything else you might have access to make updates for that gets stored somewhere. And then you're just hoping that a user with privileges will go to a page that potentially runs the code that was part of the exploit. And so that's known as a blind attack. So yeah, it generally occurs when the attacker's payloads is saved on the server and reflected back to the victim from the backend application. For example, in feedback forms, an attacker can submit the malicious payload using the form, and once the backend user or admin of the application will open the attacker's submitted form via the backend application, the attacker's payload will get executed. Yeah, so it's a stored cross-site scripting attack, but you don't necessarily know where that code is going to be run or who's going to run it, and you're kind of just hoping that someone with privileges does. Okay, so these are the kinds of cross-site scripting. Let's jump into how do we prevent it, how do we fix it, and then also look at some scenarios where you will be potentially vulnerable to cross-site scripting. Does this come from ChatGPT, Mark Boots? And what's up, CloudSec Ninja? Welcome back. Good to see you. Now I'm afraid. I would guess that if it's a large, we're going to get there, but if you're using a Markdown renderer, you want to read their docs. Most Markdown renderers typically have documentation on preventing cross-site scripting and injection. So NGX Quill, if it's a popular library, they probably sanitize the input. Okay, Mark has a comment on how clickjacking and XSS are related. So while both clickjacking and XSS involve manipulating the behavior of web pages, they do so in different ways. Clickjacking focuses on tricking users interacting with hidden or disguised elements, whereas XSS involves injecting and executing malicious scripts within the content of a web page. Yeah. Yeah. Web App Hackers Handbook. I've actually never seen the Web App Hackers Handbook. So I don't know. Oh, that's on the MDN page. Nice. Okay. Good to know. I think I need to just create an example locally to really show, so I can modify the code and like really show you where we are, where we're vulnerable here. So, I'm laughing because I'm like, I'm going to make it pretty. I'm going to go add Pico CSS. It doesn't have to be pretty. It's just a cross-site scripting example, but this is going to make the page look nice without any effort. So I'm going to throw that in there. We're going to call this XSS vulnerable. And I think I'll replicate the example that we saw on the Google that came from. or on the example that came from Google. So let's say we have an input, type is text, we'll give it the name of search. And then we'll just say, enter your search term. And let's see what we get. I'm just going to use light server, which is an auto-refreshing dev server. And then we'll also just put this in a container. Okay, so we can enter our search term, and right now there's no server side involved. This is all going to be client side code. But you'll notice by default, I haven't written any JavaScript yet, but when I submit the form, it actually updates the query param in the URL. And so now, if this up here, so if we take advantage of that and write some code that's pulling in that value from the URL, that's when we will potentially be vulnerable to cross-site scripting. So I'm going to add a little script right here. And inside that script, we're going to write some code that gets access to the query param. So we can do URL search params, which is built into the browser, and then pass in window.location.search. And then we can grab the search term as if we do query.get search. And if that exists, for now, we're just going to log it to the console. And then once we make sure that we've gotten it, we'll actually add it to the page to show how we're vulnerable. So yeah, you see when this page loads, it just says hello right there. So literally anything I type into the search box, the page will refresh, and now the query parameter gets updated with that, and then we get access to it. So we could do something like this. So you, let's just give this a little div. And we'll give this an ID of example. And we're just going to replace this entire div on the page according to what happened here. So we're going to grab that element. We'll do document.querySelector to grab the element with ID example. And we will modify it here. So what I'm going to do is, if that search term exists, we're just going to replace the entire example element with some of my own content. So in this case, I'm just going to do like an H2. Thanks, hum up. Appreciate you. Yeah, and we talked about this earlier, Svensek. So if you rewind the stream after, we'll talk about how they're different. But cross-site scripting is specifically a vulnerability on a client-side web page. SQL injection would be a vulnerability in the back end when you're executing a SQL command that potentially has some user input involved with it. It's similar in that it involves user input, potentially malicious user input, but they're happening in different places. Yeah, and then we can just say you searched for, and then we'll throw in right here the search term that they searched for. So that's it. That's all. So do I want an H2? I'll just put this in I want it on a new line. Put in a little div. There we go. So it says what you searched for. And then let's just add a little button at the top that says search again. Actually, it'll just be an anchor tag that goes to the root without any query params. So if I click this, we go back here. Actually, I'm just going to make that part of the template so it's not on the homepage. We'll get there. Give me a second. we're almost there. And then I'll show you how we can exploit it and how we can make it not vulnerable. Okay, so you go to this page. You search for something like banana. You click enter. That then reloads the page, and it tells us on the page what we searched for. And so this is a classic example of being vulnerable to cross-site scripting because I am not sanitizing that search query param right there. I'm literally injecting it directly into the page. So a smart person, a smart hacker, a curious person would be like, oh, well, let's test the limits of this. What can I put in there? Could I add an image? And will it actually render on the page? Let's see. I searched for a kitten. So this is bad news. If you can actually see rendered elements, you definitely know that the page is vulnerable to it. And Gringog, welcome in, Raiders. Good to see you. Welcome to the Coding Garden. We are learning about cross-site scripting today, and you arrived at the perfect time because we're about to exploit this website. Yeah, you could do literally whatever you want. You could embed a Google map. You could do a bunch more stuff here. But let's show the classic example of how we can execute some scripts here. Now, you might actually be tempted to inject a script directly, but these days a lot of browsers will prevent you just from injecting a script directly with setting inner HTML. So let's try this, and let's see if this works. Yeah, this doesn't work. And if we look at the actual rendered page, we can see that you searched for, the script is there, but the browser is actually preventing that from executing because it was set here with inner HTML. I will break for advertisements, but when the advertisements are over, I'm going to show you how we exploit this, and then also how we can prevent being exploited. So I am going to color a picture for the next 3 minutes while we wait for the ads to be over. So it should have showed the less than or greater than signs in the text instead of considering as an HTML element. Exactly. That's what we want to see. We want to actually just see what the user typed. We don't want to render it. So if it would have just showed script, or if it would have just showed like image with the less than or greater than and everything else, that's the best case scenario. Is we're not running that user code. We're just setting it in the element. Okay, 3-minute break while we wait for the ads. And today we have the Bob Ross coloring book. I'm going to add an overlay really quick, though, that tells people we're on break. Cool. Yeah, we're gonna color the Bob Ross coloring book. I think I'm just gonna start at the beginning. I haven't even started coloring this at all. So, honestly, yeah, we'll start here, which is a winter landscape. Let's make an almighty mountain. Everybody likes mountains. No matter if you live in Florida or Alaska, mountains are still pretty. I agree with that. And what's up, Oscar? I'll probably have enough time to color this nice green tree right here. And what's up, the Shivas? Good to see you. Actually, they're supposed to be snow-covered trees, aren't they? Snow is really hard to color because it's just white. I guess if you're colorblind, this may not be green. But I'm letting you know it's green, so now you know. It's this happy little tree. Oh, the ads are running on Twitch. I mean, if you want an ad, I'll give YouTube an ad. There you go. YouTube has an ad now. I mean, I know you don't want an ad, but it's the nature of these things. I'm a little bit out the lines, but this is the nice thing is this has these are erasable colored pencils because I make mistakes. I think we want probably like a brown. Here we go. Here's brown. It's true. There are no mistakes, just happy accidents. Yeah, you all are right. I can't believe I forgot. Oh, thank you. Yeah, and I think Oscar commented as well. I appreciate that. I cut my own hair, surprisingly. I mean, I haven't gone to a barber in 12 years. I contemplated going to a barber, and then I did a bunch of research, like which barber should I go to, and then I just cut my own hair. We're gonna color one more tree, and then we'll be done with the ad break. Done. What pays more per stream, Twitch Turbo or YouTube Premium? I have no idea. I almost feel like YouTube Premium. Let me know on YouTube. Are the ads done over on YouTube? And then we'll get back into it. Oh, reverse coloring. My wife has a reverse coloring book, and I don't know if she's used it yet, but it Mike, thanks. It honestly looks daunting if you're not used to like drawing, because it's just the color and you're supposed to draw the outline. Okay, back into it. So where we were is we have this simple example of a page that's vulnerable to cross-site scripting. The example we showed here is I can actually inject an image. And it actually gets rendered onto the page whenever it shows us our search term. And somebody asked the question earlier, well, how would we know if it wasn't working? And the main way we know is instead of showing an image, we actually want to see the text that the user input. And so let's learn one of the ways to prevent this, which is don't directly include user input in the HTML. So we'll call this one vulnerable. User input directly set in HTML. But let's show an example where we don't do that. So what we might do is something like this. So we set the inner HTML to stuff that does not include user input, and then we can create an element and set its text content. So we can say the like the search term element is a div. And then from there, we can set the inner text or text content. I always just default to text content, but you can search for the differences between inner text and text content. They mostly work in the same way, like this. But essentially what I've done is I've created an element. I've set the text content. You'll notice we're not setting HTML, we're just setting text content. And this actually takes that and places it as the text content of the element, which doesn't get rendered as an image or whatever element it might be. And then now that I have this element, I need to append it to the example element. So I can just say example element.append and then append that search element. And just like that, we're no longer vulnerable. So because we're not setting inner HTML here, we're literally just putting it onto the page. Now we're not actually trying to render that content that came from a user provided value. And so this is one way to do it. And I mean, you could fall on two extremes potentially if you're doing like vanilla JavaScript, where you could say, I will not use inner HTML anywhere. But the issue with that is then your code is going to get really verbose, right? So like the DOM manipulation and directly creating elements like this isn't ideal. Like especially if I would have done DOM manipulation here too, or if I would have created an A element, set the attributes, created an H2 element, that gets pretty cumbersome. So this is more than fine though, especially if you're doing this for any area that has user provided values, you're no longer vulnerable. So here we go with this one. Not vulnerable. Uses node text instead of HTML. Inner text is only the visible text. Text content is the raw input. So maybe it's safer to use inner text then. Good to know, Nishojib, who mentions there's a set HTML. I haven't heard of that one. Used to parse and sanitize a string of HTML and then insert into the DOM. It should be used instead of element.inner HTML for inserting untrusted strings. Wow, where can I use it? Nowhere. It's really, really new. It's really new. But that's okay. Eventually, if this gets added to the web browser, that's awesome. That's really cool because then you potentially don't need to reach for an extra library, which is what I'm about to show you we will do. No, it's new. It's experimental. Yeah, and it's experimental, which also means it may not make it into these browsers. Like the way that the specs eventually get implemented in web browsers is similar to the way that JavaScript features get added, in that first web browsers need to provide like a reference implementation, and they're just they're figuring it out and making sure that it works. And then from there, once they have multiple browsers that have all implemented it, and everyone can agree on the API and how it should work and everything, then finally it'll become a standard browser feature. Apparently, they might be the stewards. So the other concept here is there are various people on the board of the WhatWG and the is it WhatWG? Yeah, the W3C community group, like basically like their working group. And it's possible that the steward for this document has ties to Samsung, which is why it's supported there first. Regardless, this is cool. It's cool to know about. Thank you for bringing this up. Who was this? Nisho. Yeah, appreciate that, Nisho. Okay. Yeah, this is not vulnerable because it uses node text instead of HTML. And the thing to note here is node text, it does not render content. It only displays it. Okay. The next step is to sanitize, or the next thing you could do is sanitize your input here. And this example is nice because we can continue to do like the inner HTML thing that we were doing before. But we will sanitize that search value when we're setting it here on the search element. But we need a sanitize function. So we might have a function here called sanitize HTML. And you might just think, let's just replace every occurrence of a less than or a greater than. Do I need to escape these? We'll do this globally, and we'll rescrape it with not this time, hacker. Maybe this will work, but basically we're stripping out the less thans and the greater thans, and by doing that, now we're just adding it there without the less thans and the greater thans. Let's see if this works. This doesn't work. I did it wrong, apparently. Do I not need to escape? Oh, I guess the other issue is they're HTML encoded. Oh, you're right. I didn't call it. Good call. Thank you, Lambda Limit. I was like, what's happening? No, I need to literally call it right here. Yeah, the kitten won this time. So we need to actually call our function right here. Yeah, good call, everyone. There we go. Not this time, hacker. And so I say this is not vulnerable mostly. So I'll say we write our own sanitizer function. It's not vulnerable mostly because there's more to think about than just less thans and greater thans. And then there are other scenarios where it will be potentially inserted into the DOM where it doesn't really even need less thans or greater thans. For example, if it was an attribute itself. So let's actually introduce another vulnerability where we put it on the attribute right here. And we say, let's say we're adding a tooltip on the title right here. And if we put the search term right here, now we actually will be vulnerable, but in a different kind of attack. And I do believe title adds the tooltip, right? Let's see. If I search for kitten, and then I hover over kitten, yeah, that's what gives us that little tooltip, is the title attribute. But now we've introduced a different place. Now, I'll even show you. Even if we pass this in here, I can exploit this because I'm a hacker man. Now let's try to exploit this. And let's think about it, right? If we're literally taking that and putting it into the page right there, what could we do, right? Basically, we could break out of the title attribute, right? So like if I said the search term was something like close quote space, yeah, I guess at this point, do we have an onload function on divs? I don't know if we do. I don't know if we have like events. I don't know if we have onload. Let's try it. It could be that we potentially would want this on an image or something like that. Is there an on error? But it is just a div though. Yeah, but it's not an image. I guess here's the thing. No. Okay, no. I could use on error, but now I could just break out. Well, I can't. I couldn't break out because we're replacing less thans and greater thans. Yeah. All right, let's just try this. And then there's like another double quote like this. And so basically I'm going to attempt to inject this right there. And you'll notice it doesn't have any less thans or greater thans. Let's see what happens. So if we look at the actual what gets rendered here, you'll notice it actually did put that attribute onto the page. I just need to figure out, is there, I mean, one thing we could do, which I mean, isn't, oh, that's funny, Drop Me. I mean, that's another kind of injection. You're totally right. We can at this point we have attribute injection, so we could inject a style tag here. Would the body work though? I don't know. But one thing you could do is like mouse enter. So like this is a DOM event that can be added directly, and now oh, I have an extra quote. Here we go. Div example. Oh, it's invisible. I guess at that point I could inject the style tag and do something to it. But regardless, is it on mouse enter? Let's try it. Let me figure out a way to not break the div. So if we do single quote, it's going to close the first one. We have our own attribute, but then we have this dangling quote over here we need to do something about, which is why I thought we needed this, because then it would be test equals colon or quote test quote. There we go. Oh yeah, and now it says pwn. So the moment my mouse enters, it actually runs the code. This isn't ideal because this requires more user interaction, but we still technically have injected. We're in. We've still technically injected some codes. And so really the only point I'm trying to make here is there are a lot of different scenarios that you have to think about. So it handles elements, probably. There potentially could be HTML encoded entities that would still actually would those still work? We can actually try that to see if it's still vulnerable. Also need to handle attributes. There's a lot of things we need to handle that would require a lot of our own code, which is basically why I'm saying don't do this. Don't just write a simple little replacer to prevent injection. You want to use a tried and true, tested, security hardened library that has handled all of the edge cases and has a bug reporting program where people find bugs in it and they get fixed quickly. Cool. Live Overflow did a video about it. I'll have to check it out. Should still be vulnerable to simple obfuscation. What about autofocus or onFocus? It's technically just a div element, though. I'd be curious if this is vulnerable to HTML encoded entities. Yeah, like these. Ampersand LT. Add content editable. Oh, that would be funny. Because then you could just make it so someone can... Entities appear as their character, but are not. Let's try it. So because we're not escaping those... So in this case, I'm trying to use the HTML entities. So basically we have the less than image stuff. Let's see if this works. No, it doesn't get rendered because I think technically this is one way to escape them is replacing them with their corresponding entities. Yeah. Oh, well, this is why I'm going to try a bunch of challenges today so I can learn more about potential ways to exploit something that's vulnerable. Because I have this feeling that even though we're replacing less thans and greater thans, it's still vulnerable. I just don't know how to exploit it yet, and that's why I'm gonna learn today. Can I try a web proxy like burp to resend the search query after the request is supposed to have been sanitized? Well, the thing is, all of my sanitization is happening client side, so there is no backend server in this case. The query params are only being interpreted on the front end. So I think burp would see the network request to my backend and then the response. But in this case, it's literally just a static file. It's just this HTML. It's not being rendered or anything. Okay, so the last example is to use a library. What's up, Mindcoded? Welcome in. So we're going to use DOM Purify. And DOM Purify has a function we can use, very similar to sanitize HTML, but we can just use it. So yeah, it's over on Unpackage, and we can just add it directly to our page. If you're in an environment that isn't just a web page. You can also install it from npm and then pull it in. And then let's go see their docs on how do we use it. But yeah, look at this, 12,000 stars, only one open issue, updated yesterday. You're right. Thank you, Massive. I do silly things. Honestly, I feel like, more especially lately, I do silly things. I used to be really on top of it. I used to not make any typos. I used to be able to type faster. I'm declining, but here we go. dompurify.sanitize, and let's just use the defaults and see what happens. So right here, this old age. That's probably what it is, isn't it? Yeah, and then you saw me. I'm defaulting to all caps elements. Here's the thing. I never did web development when this was the style. I don't know why I did that. I don't know. Okay. Oh, thanks, Stoney. I do think I'm getting better, though. I was burnt out for a long time. I think especially, I mean, if you've noticed the past 2 weeks, I've been pretty consistent on Coding Garden, streaming often, editing videos. So yeah. Cool. So now, you'll notice it's purifying it, and let's see what it actually is adding to the page. Yeah. It is getting added right here. But you'll notice it's stripping out the on error attribute. So it leaves it as is in this case, but it's kind of just stripping out the on error attribute. There are more options in the library to say if we have an allow list or a not allow list, or what attributes do we want to allow and stuff like that. Yeah. Yeah, and yeah, I know, Ryan. Me neither, but I'm doing better. I'm doing better. Yeah, and then you could also, the other attribute here is you could run it on the server, and so this running it on the server is one way to prevent stored attacks. If you're always running it on the client, you're at least preventing it from running on the page itself. But if you run it on the server before you put it into your database, then you're less likely to have a stored attack because it gets stored. Purified without all the extra stuff. XMP is allowed? Is that true? I'm trying to see what are the options that I'm missing here. Because yeah, here's some more options. Like you can specify allowed tags. Like let's say you want to allow people to use paragraph tags and stuff like that. Then this uses an allow list, and anything that's not in the allow list will not be rendered. And let's actually do this. So like, because let's say you did want to use DOM Purify for something like Markdown or something like that. You could use a Markdown library, potentially a Markdown library that doesn't do any sanitization. Generate the Markdown and then pass it to DOM Purify and say, hey, don't allow scripts, don't allow canvas. Basically, the only thing you should allow are like text elements. So if we do allowed tags like p tags and like h1s or something like this, now that image tag is going to get stripped out. I'll pull this into an options object. So now it doesn't render anything at all. And so you would definitely want to look into this library to make sure you're doing the right things according to your application. So in this case, you'll notice it just, because I tried to inject an image tag, it just stripped it out entirely. It's only going to allow p tags and h1s. And technically, now we can do fun stuff like this. And it actually gets rendered on the page, but that's because the application has allowed it, and you mostly can't do anything harmful with those two like text elements. The other thing is it has options for tags. So you can do forbidden tags, forbidden attributes, or you could do like allowed tags or allowed attributes, I think. Yeah, allowed atter. And in this case, they're adding style, but we could pass this in as nothing. And so you can do p1s and h1s, but strip out any attributes. And that's handled there as well. Okay. So, and that's a good point, our Popa, and that's kind of why I added this allowed attribute. Let's see if we can inject an on-click, and I think we probably can, unless I do no allowed attributes. But yeah, that's basically why I did that. So let's try it. So if we try to inject an h1, and then we have an on-click. Looks like it strips that out automatically. I think we could do the reverse where we allowed attributes. If we have to explicitly allow it, and then it will get it won't get stripped out. Yeah. So it's nice that it's kind of like opt-in at that point. But you should definitely look into the docs for this library. Make sure you're using it in the intended ways, and you're only allowing things that you actually want to allow. Great. Where were we? Yeah, so ultimately the way that you prevent it is by first avoiding using inner HTML on user provided input. And I guess it's good to describe what user provided input is. So here we just have sanitize user provided input. So this is anything coming from a user. In our case, it's just whatever the user typed into the search box. That's the user provided input. But user provided input is also things that people are setting values in their profile, or if you have a website where a user can create things like create a post of some kind or a comment, that's also user provided input. And so anything, basically we should never trust anything coming from users, because hackers at the end of the day are just users of your application. They're malicious users because they have malicious intent, but they are also just using the same application that everyone else is using. And so if you basically trust no one, that's the best scenario there, where regardless of what it is, if it's coming from a user, you always sanitize it and you never put it somewhere where it could be directly rendered. That's the number one key here. And this is the same advice to handle SQL injection, to handle command injection. Just never, ever trust what the user is sending you at. Trust, but verify. And in this case, we're not even verifying. We're just like, yeah, we'll just use DOM purify, remove anything that they tried to do, and you're good to go from there. And so specifically, if we're talking about DOM manipulation here, not using inner HTML is kind of key. Like I avoid inner HTML. Absolutely. I potentially use like a template engine, but then also if there is and this is also if I'm not using a front-end framework like Vue or Svelte or React or something like that, because we'll talk about those next. Those automatically handle this sanitizing, and it handles it in the framework itself, unless you try to break out of it, which I'll show next. But yeah, just don't use inner HTML basically. Like if you know that if you're not using user provided input, inner HTML is totally fine. But the moment you start to add variables in there that came from a user, that's when you're going to run into trouble. And then the best advice here, and this is what I typically do, is just use text content or inner text. This will never be rendered on the page. It always is just the text that the user or just the text itself, and it gets just displayed on the page. It's never going to get rendered if you use text content or inner text. You're basically guaranteed to not be vulnerable if you use either of those two. And then the last bit of advice is don't try to implement your own sanitizer function. There's just too many potential scenarios that you probably haven't thought about. So you could try it, but you are better off if you use a tried and true tested library. But yeah, so DOM purify should do nothing to your previous cross-site scripting attack in title. Oh, I see what you're saying. I think it did sanitize it though. So because I said various elements weren't allowed, I do think those got stripped out. I guess we'll try it. So if I close it out like this. Yeah, you're completely right. At this point, we're actually still vulnerable to we're still vulnerable to attribute injection. How do we prevent this? Yeah, thank you, Andrew, for mentioning that. We'd have to think about this. Like, what would we need to do here to make sure that we're not vulnerable to attribute injection? Yeah, so the main vulnerability here, America 2050, is taking this link and getting someone else to click on it. That's the main vulnerability here, because or just sending this link to someone you know that uses this specific website. Using set attribute, that's probably a good idea as well. Yeah, like you can literally, after we've added it to the page, select the element, do set attribute. Yeah, that's the only thing I can think of. Huh. I'm curious if DOM Purify has a sanitize attributes. Here's the thing. We use the attribute test. What if we try like on click? No, that still gets injected. Okay. Basically, what I would do, if you really want to render the HTML from a user, I would combine these two. Where, why did I just copy that? No, not this one. Like this. So we have this, and then we have the user search element. So we manually create a div. We do set attribute title, and we set that to be what they passed in. And then from there, if we still want to use the HTML, we can do user element.inner HTML and set that equal to DOM Purify sanitize. So this is how I would prevent the attribute injection. Create the element, and then we create the search element, set the attribute, set the inner HTML, because set attribute is it should escape our input here. And at this point, we can append the user search element to the example element. Let's see. Really? Did I save my document? Set attribute is still injecting it. Right? No. It's not. I don't know why it wasn't. Maybe I was loading the cached version. Yeah, okay. I was loading the cast version. When I use set attribute, you'll notice how it's purple. It's actually being set as the string for title. Okay. Cool. Cool. Let's keep moving. This was fun. I'll answer any of the other questions that you might have, and I think I'll show some examples of having this vulnerability like in a React or a Vue app. I think that's what I'll do next. Let's make a React example. We're just going to create a little Vite app and then show how we would be vulnerable with React. Not vtest, Vite. Is it just npm create Vite? Okay. I'm just going to rip out all the existing styles and everything. So it's super basic. And then we'll just have the exact same example and show what happens when you're running the same code inside of React. Ooh, okay. I've been to DEF CON 2 or 3 times. I'm a very shy person, and it's really hard when I go to conferences alone though. Yeah, I mean, the multiple times that I went, like I didn't talk to a single person. I might go this year because I'm looking more into like AppSec and application security. So yeah. Okay. What do I want to do? This. I want this codes here. So in my React example, we're gonna do the same thing. We do have to make things not self-closing, or we have to make them self-closing. Like input needs to be a self-closing element like that. And then we'll add Pico to our React HTML. Cool. All right. Basically there. This is scary. I'm a web dev and I'm scared of things that hackers can do to me. Well, the best thing you can do right now is be informed, right? So that's basically what I'm doing is I'm making people aware of these things so you can think about them when you're building your application. And what I'll show you is if you use something like React, you're mostly protected unless you try to escape out of their protections, and that's when you're going to be vulnerable. So that's what I'm going to show you here. So we're almost. I basically just have to recreate this whole thing with with a little component here. So when the app loads, we're going to get the search params. Actually, we can just pull them out here. And actually, I'll just copy this code. Mostly protected is not remotely true. Expand. Oh, yeah. And I would assume that people know that that's what I'm saying is when we're specifically talking about cross-site scripting and user-injected code. There are other things you need to worry about, which are not cross-site scripting. But again, it just comes down to awareness. Cool. So we have the search here. We'll just say, if search is a thing, we're going to render this, else we're going to render this. And the thing we want to render if search is a thing is this. But we're in React, so I don't need the $sign. Okay. I think we're there. Thank you, I am Will Shepherd. I'm doing my best. Just today, I worked on my blue screen and everything else, getting everything else worked up. We also have this scene. Now I can come over here. Oh, not microphones. But I have 2 microphones on my desk now too. You can see it over here. So yeah, I appreciate the comment, the compliment. Okay, if there was a search term, show this text that says you searched for and put their search term right there. Otherwise, we're going to render the form so that the user can search. Here we go. So now let's try the classic vulnerability where we have just we try to load an image and then specify the on error. And let's see, are we vulnerable inside of React? We are not. And we didn't have to do anything, right? You'll notice I'm not calling DOM purify. Even here, if I try to set the title to search, this one will not be vulnerable to attribute injection. Absolutely not. So now if we look at this, you'll notice that it just all gets put into the attribute there. There's no way to break out. I mean, I can try breaking out. So again, if we do, yeah, there's no way to break out. There's not even double quotes here. But if we assume that, okay, let's say I do a double quote to close it out, and then we try to add our own little on click. And then we need to close out the other attribute. You'll notice the way that React and the virtual DOM are rendering these things, all of that content is just the attribute text. Under the hood, it's using set attribute. We're not going to be able to break out from there. By default, just using React, we're not vulnerable. But what I want to point at is the one place where we would be vulnerable is if we decide to use dangerously set inner HTML. So if we did something like this, if we said dangerously set inner HTML, and then here, I think it's an HTML attribute, and you set it like this, but it needs to be an object like this. Okay, so now if we were to basically break out of the protections that React gives us with dangerously set inner HTML, now we are going to be vulnerable. We're absolutely going to be vulnerable. And we'll be vulnerable to just this one. Because we explicitly said, hey, we want to set the HD inner HTML, and that is why they actually call their attribute dangerously set inner HTML. If you have a linter set up, pretty often you'll have a rule, like a React linting rule that says, hey, don't do this. You could combine this with DOM Purify, so that's another option. Let's install DOM Purify in this project. What are the valid reasons? Yeah, so if you're doing things like markdown rendering, or like even if you're building, let's say, a blog, like sometimes you do want to render user provided content. Sometimes you do want to render like p tags and title tags and different things like that. But you don't want to allow scripts or canvases or anything else that will potentially allow for other executions of codes. So in this directory, in this React app, I can install DOM Purify. And then we can import it in like this. Yeah, and I guess like sometimes maybe even, I mean, it's hard to say, but if you're building an internal application and you know the only people that can ever run that application or ever have access to it are trusted users, maybe at that point you can say, all right, we're not going to purify anything. But I would argue that you can't ever you can't ever guarantee that, because that's another potential attack vector. Because let's say a hacker gets into your systems and internal systems and then gets access to that app where you weren't sanitizing user inputs. Now they could maliciously inject something. So like you can never truly trust all the users of your app. All right, why is this complaining? Cannot find declaration file for module DOM purify. Oh, because I don't have types. Bad coworkers, disgruntled coworkers. Yeah, cool. Oh yeah, we need the types then. I mean, we don't need the types, but I'm gonna install the types. Insider threats, exactly. Okay, so now at this point, I'm breaking out of dangerously set inner HTML, or with dangerously set inner HTML, but I'm using DOM purify sanitize just to be sure, And now we'll restart our app. DOM purify.sanitize is not a function. Well, do I need the isomorphic one? If you love working with Angular and the like, import star as DOM purify. Let's see if TypeScript will help. Or do I need to create it? It says it exists. Let's try this. There we go. This is still vulnerable. Why is this still vulnerable? Oh, because we didn't disallow images. It sanitized it, but I think when it sanitized it, it just removes the on error attribute. So if we pass in an image and it has an error, we won't be vulnerable to this because by default, DOM purify is going to strip that out. Yeah, so by default, we pass that in and it stripped out the on error attribute. But again, like I showed in the vanilla example, you could specify what do you want to allow, what do you not want to allow, that kind of thing. Cool. Modern text editors using Markdown are a great example where you need extra sanitization. Yeah, I guess if you're using like a web-based content editor or something like that, yeah. For fun fact, I use both dangerously set inner HTML and eval in my React app, but it's sanitized and tied to the user. Stony likes to live dangerously, but yeah. How to be fully secure? Just don't build the app. Yeah, I guess don't even. Just go live in the woods, basically. Yeah, I think this is a great summary from Lava in the Lamp. Good rule of thumb: avoid using this. But if you do have to use it, you should still be using a sanitization library as well. And ultimately, if you're using user provided input, right? If this is coming from a user, you should sanitize it. Plain and simple. In 20 years, will we still use UI? I don't know. Hopefully by then we can control things with our brains, but maybe not. I've thought about this a lot. Like a lot when I was younger, like imagining like the sci-fi future and like, oh yeah, one day we're all going to have our brains uploaded to the cloud and then we'll never die. But what you don't think about is that who owns the cloud? It's Amazon. And so at that point, Amazon owns your consciousness. And I guess the same thing, like if I'm getting a brain implant to be able to control computers with my brain, what company made the brain implant, and are they in control of things? Are they like servicing me ads? Are they in control of my dreams? Yeah. Is this just web dev or any programming language? Any programming language that will be potentially rendering content to be loaded into a web browser. A good example of that is this XSS game, which you can all go try this right now. Basically, there are several vulnerable pages that you can try exploiting. But it's interesting to show because when they show you the source code, they are showing you the backend source code. Like there's a server that's actually serving up this page. And this is an example that's a combination of like client-side code, but then also like backend code. And the reason Python needs to be worried here is because if you're if let's say you're using a framework within Python that allows for rendering web pages, you should be sanitizing any user input if you're injecting user input into the rendered page. And so in this example, it's rendering this page, and the user posts are getting displayed on the page itself. So if a user posts something that has some code in it that could be executed, that's just going to be rendered onto the page. This is like a sandbox example of basically what happened on Twitter with that cross-site scripting vulnerability on Twitter. Yeah, and this is an example of a stored cross-site scripting attack because the user input is stored in a database and then loaded onto the page. So yeah. So even if you're not working with JavaScript on the front end directly, you still need to worry about cross-site scripting if you're building back-end applications that render client applications. Yeah. Yeah, I think this is something I didn't mention, but we should make a note on this as well, because how do we prevent it? Another way is a content security policy. So prevent scripts being loaded from, or we could say this: only load scripts and resources from domains we trust. Because another potential attack vector is, like, let's say you do have a cross-site scripting vulnerability, an attacker could try to load a malicious JavaScript file from some remote server. And like that actually might be the only way that they can exploit the page. If they can get their own JavaScript file executed on the page somehow because of a vulnerability that you have, then they're in. But if you have a tight content security policy, which is set on the server side and the server side headers, you can prevent loading resources that come from domains that you do not trust. And that would prevent an attack like that from happening. Yeah. Oh, earlier today, an employee of one of our clients created a promo code by removing the disabled prop on a button he shouldn't have had access to. I think that's in reference to like insider threats. Yeah. We're live on YouTube right now as well, so that same URL is where you can watch the stream after. Yeah. Go live in the woods, yeah. Do we still need to sanitize the user input if we're not setting the HTML and just using the input for some calculations? Probably not. I think that's the main thing to show, like especially in the React example, is if we just want to render it, we can just specify it right there. We don't have to sanitize it. The only time we sanitize it is if we're trying to set that inner HTML. Yeah, stored cross-site scripting on a brain implant, like the UI that gets displayed on your eye actually has a cross-site scripting vulnerability. Hey, what's up, Kaizen? It's been a long time. Are you still making videos? Thanks for being here. Oh. Yeah, there you are. Last upload 4 months ago. That's okay. Go watch Kaizen. He's a long-time viewer of the Coding Garden. Yeah. If you're learning to be backend, is that worse? No. It's just, I think that's another part of the awareness is just because you're not working with client-side JavaScript directly doesn't mean you potentially couldn't create something that's vulnerable to cross-site scripting. That's really all I'm saying is even as a back-end dev, you should be aware of it. What comes to mind is I know one of the challenges for Juice Shop is actually an API-only cross-site scripting. And so this is going to be an example of a stored attack where the attack actually gets stored in the database because their API is a JSON API. And so basically, we find an endpoint that we can send data to that gets stored in a database, and then because it's stored in the database, it gets reflected back. So one of the fixes here is if you're working on that backend API, you sanitize the input that comes from the user, especially if you know that that's eventually going to be rendered onto a page somewhere. Yeah. What's up, Luna? Are there any free hosting right now? It depends on what you want to do. Vercel is like fairly free. And then there's also like render.com, fly.io. They all have free tiers. Portswigger Labs are free as well. I was finding some really good resources from Portswigger. They have this article on cross-site scripting that has like some really good diagrams and descriptions. But before researching this, I hadn't heard of them. Yeah. No worries, Kaizen. Thanks for being here. I keep seeing messages from Clarkio. Is he just doing drop or is he trying to inject? Trying to inject. Oh, here we go. Trying to add some animations. Nice. I just got here. So is React by itself XSS safe when you don't use something like dangerously set inner HTML? For the most part, yes. It's still possible that internally they did something that's vulnerable, but ideally that would be patched. We could try to see if there's like a CVE for React.js cross-site scripting, like if it has existed in the past. Let's see. Come on. Is React foolproof? That wasn't useful at all. So what I would want to see is a specific security vulnerability bulletin that describes how React was vulnerable. But we're on an ad break, so I'm going to break for 3 minutes for ads, and then when we come back, we're going to start to do some Juice Shop challenges, and then also answer any other questions you might have about cross-site scripting or anything else that we haven't talked about yet. So a quick ad break, and we'll be back soon. Yeah, let me also catch up on the chat. I see you later, Secret Val. Never sanitize the input, only the output. That's all right. Yeah. Cool. What if I want to get a job? Nothing's stopping you. So yeah, if you're trying to do web dev, you should know about security. I think if that's the main thing you take away from today, I think that's perfectly fine. Like security is not someone else's job. If you're building websites, you should worry about security. Those trees are water streams. I think this is a lake. Yeah. Yeah. I don't have any courses that I recommend, but Udemy is fine. You would want to look at reviews and stuff up for the courses you take on Udemy. And specifically, if you're looking for web dev, there's a ton of free online courses like Free Code Camp or the Odin Project you can check out. Yeah, it's a never-ending journey for sure. Always something new to learn. Full Stack Open, is that the one from Finland? Or Sweden? But yeah, that's another one too. If you want to set your display name on YouTube, it's called your handle. Let me find the help article for it. Yeah, here. So if you go into your YouTube settings, you can set basically your username. So just like you have like a Twitch username, on YouTube, you can go there and set it. And so my overlay displays your handle. And so because you haven't set it yet, that's why it's showing that default value. But hello, Ryan. Yeah. Yeah, I have a React course. It's not for complete beginners, though. You have to know about web development. ReactRoots.com has info about the course. Mic is visible. But this section these are all the things you need to know before taking this React course. Because learning to code with React directly would be very hard. There's just so many underlying concepts that it's hard to gloss over if you want to be able to work with React really well. Okay. So yeah, somebody had asked about, well, if we just use React directly, at that point, would it ever be vulnerable to cross-site scripting? And the answer is possibly, but it's just if some of the internals somehow were not written in a way that were secure enough and could be exploited. Yeah. Courses are fine, but you shouldn't just take courses. In order to learn, you need to practice and build things. So the advice people have are, well, not that you can't learn anything from courses, it's that if you spend all of your time just watching videos or just doing exactly what the course tells you to do, it's going to be very hard to make the jump to building your own things. So the advice is take a course, sure, but make sure that you try to apply the information that you learn to really show that you've actually learned it. So yeah. Okay. Any last questions or comments about cross-site scripting before we try to do some challenges? So basically what we're going to do at this point is I'm going to learn more about cross-site scripting because we're going to spin up a vulnerable web application and do our best to exploit it. Like I've showed, I know some things about cross-site scripting. I know how to try to inject an image tag, how to try to break out of attributes, those kinds of things. But we might come across some vulnerabilities that aren't that easy to exploit, and we'll have to learn what are the possible ways to exploit it. The thing that I didn't talk about earlier is, like scanners and static code analysis, but basically these are tools you can run that will identify places in your code where you might be doing something that's vulnerable to cross-site scripting. Like, for example, ESLint has a rule that says you shouldn't use this anywhere in your React app. And if you enable that rule, now you have this tooling that's basically there to let you know that, hey, you're doing something that could be vulnerable. Yeah. This is the other thing I do in my overlay. If you try to embed an image URL, I swap out the URL for this. Yeah, there was an attempt. And I'm actually handling that at the network level inside of Electron. So I have an allow list of like domains and IP addresses, and if it attempts to load something that isn't one of those domains, and in this case your domain was just the letter X, but if it attempts to load something that's not that, it just swaps out the image to be that. Okay. So yeah, and actually let me know, Clarkio. So Clarkio works over at Sneak. Does Sneak have static analysis tools? Like, does it have something you could run on your code that will tell you if it's like vulnerable to cross-site scripting? Like this. So Alka is allow listed. So I allow Alka's domain. That's why he can do that. What's up, Alka? Sneak. Oh yeah. So I found it. Yeah. So this is a kind of tool that you can run at your organization, which will analyze your source code and let you know if you're doing something that's not a secure coding practice, or if you're doing something that might be vulnerable to cross-site scripting. And there are other tools like that. Isn't it pronounced Schnook? Schnook? I have no idea. Can you type out the phonetics pronunciation for Sneak, Clarkio? I always called it Snick, and then I think maybe I tuned into a Clarkio stream and I was like, oh, it's Sneak because you're sneaky, like you're a hacker. Yeah, Sneak, cool. Yeah, and then we answered this question: are we protected if we use libraries? Mostly. We'll say libraries have an escape hatch that allows you to directly set HTML. If you use that, you're on your own. And so we showed in React, it's called dangerously set inner HTML. In Vue, it's literally just called VHTML. In Svelte, I forget what it's called. Does anybody know what it's called in Svelte? At HTML? At HTML. Special tags. Here we go. You should have never told me what the Vue equivalent is. So that's the funny, because we are using Vue.js for this overlay. So if you get an injection, you might try to do VHTML. Yeah. Legacy.reactjs.com. Dangerously set inner HTML. Here we go. Yeah, and so we talked about this a little bit earlier. Bino? Is that your name? Bino? Why would you ever even want to set the HTML? It's usually because you actually do want to render the content of a user. So yeah, so what Codex is mentioning is like a CMS, so that's a content management system. Let's say there's an admin dashboard where non-technical users can add some content in that then gets rendered onto the page, or they have a WYSIWYG, which is another vocabulary word, which is a what you see is what you get editor, the kind of editor where basically like Google Docs. Google Docs is a WYSIWYG editor in that you're creating like you're changing the font size, you're changing the color, the formatting, and what you see is what you get. And there are other embedded editors like that on the web when you have especially like CMS content or like user provided content. I think the easiest example is some kind of blog post where or a blog website where you want to be able to render the content that a user provided. Or you have a system where people can add comments that are written in Markdown or something like that. Yeah, we were talking about this earlier, Kaizen. This thing for a moment was vulnerable to cross-site scripting, and then for a while there were various tags that we didn't account for, and then people were injecting that kind of stuff. Is the black window flickering? No, I think I don't know how to fix it. Like, as far as I can tell, is it flickering on YouTube as well? I think it's a Twitch thing. It's like a Twitch encoding thing, because I don't think it's flickering on YouTube. You all can tell me. But yeah, I think it's a Twitch encoding issue. Yeah. Not noticing it? Okay. I've seen it before, though. Like, the dark areas will, like, flicker gray. Oh, well. All right, let's do some challenges. Let's get into it. Do-do-do-do. All right, I'm going to do another introduction of OWASP Juice Shop just in case this gets edited for YouTube. Hello, friends. Welcome to Coding Garden. Welcome to Web Security Wednesdays, where today we are going to be exploiting some cross-site scripting vulnerabilities in the OWASP Juice Shop. So OWASP is a... what is OWASP? I don't know. It's an initiative. OWASP is an initiative that basically tries to highlight security for IT professionals. So you can learn more about security, learn more about the potential things your app might be vulnerable to make sure that you're not vulnerable. And this is one of their projects which allows you to learn about web security specifically. So this is the most modern and sophisticated insecure web application. So the app was specifically written to have vulnerabilities in it so that you can try and exploit them. And we're going to do our best to exploit cross-site scripting vulnerabilities today. So in a previous video, I talked about the basics of cross-site scripting, what it is, how to prevent it, but there are several cross-site scripting vulnerabilities throughout the Juice Shop. This is just a list of all the vulnerabilities. Some of them are cross-site scripting, and we specifically are going to try to exploit those. So if you want to follow along, if you want to follow along and do this at home, you can go to the Juice Shop repo, and they have some steps on getting set up. You can run it locally. I actually wouldn't recommend this. I tried doing this, but the repo has so many dependencies. It's an Angular app and a backend Node.js app. And the package.json is just huge. And so if you try to run it locally, it'll work. It'll just take a really long time to install. And then I also ran into some issues, I think, running on a Mac with a specific version of Node. All of that to say, if you just use the Docker container, it should be pretty seamless. So I have Docker running locally. And so in my terminal, I'm going to pull down the image. Did I say the wrong thing for OWASP? No? Okay, cool. That's like, do I need to correct myself? This is take 23. No, it's fine. Okay, so we pulled the image down. Great. Now we can start it up. So it should just be as simple as running this command, and then we'll have Juice Shop running locally, and we can try to hack it. Cool. So it's up and running. Let's give it a go. So in our web browser, we're going to go to localhost 3000. We have the juice shop. Very good. Very good. And you'll notice that I was already playing around with it. I was already trying to do the like the basic cross-site scripting vulnerability. And actually, let me clear this and start over, because I think there's a way to reset the container. Clear. Just to make sure I'm starting from scratch, because there's a couple of there's a button to reset. Oh, here. There we go. Okay. let me click this link again though. All right. So if I visit localhost 3000, we should see it. There we go. We have the juice shop. And so this is an application where they sell juice and juice-related products. So you can see the products, they have reviews, etc. What else does this thing do? Yeah, you can submit your feedback. Now already, I can notice multiple areas where they might be vulnerable to cross-site scripting, right? So if you noticed, when we clicked into a product, it has reviews. And my hacker brain is, oh, if I can submit a review that has an injection in it, I can run some code on their website. The other thing is it has this customer feedback form. This would potentially be an example of like a stored cross-site scripting attack where I submit my feedback, it gets stored in the database, and then gets reflected when someone visits the app. And then there's also this search input box here. So this is my hacker brain that's like, all right, what are all the areas that potentially have user provided content, and where can I try to inject things in them? They changed to worldwide? They changed web to worldwide? Okay, I need to make sure I'm saying this right. Ah, let me fix that. Let me say that. Let me re-say that. So OWASP is the Open Worldwide Application Security Project, formerly known as the Open Web Application Security Project. That is an organization that basically tries to inform IT professionals about security and how to make sure that they write secure applications. Okay, fascinating. Great. Today I learned. Me as well. First try. I'm gonna splice that in the edit somehow. All right. So for challenge hunting, and actually let me show this. So now that I have Juicebox running, not Juicebox. So now that I have Juice Shop running, we can start to learn more about it and start to hack it. So the OWASP Juice Shop book is free to read online. They also have a pay what you want version, but this basically walks you through working with the Juice Shop. And so you can learn all about what it is, how to hunt for challenges and various other things. And one of the first things we need to do is find the leaderboard, because built into this application is a hidden page that will show you your progress. It'll show you the things that you have solved, and we need to find that. And one of the things you do as a hacker is you try to find web pages that may not be public. Like there isn't a link to the leaderboard anywhere here. And so last week when we were learning about hacking over on Hack the Box, we specifically had a challenge where there was a hidden admin page on one of the web apps we were trying to hack. But we used a tool called GoBuster that like found all the possible, well, that attempted to load all possible URLs and eventually found the administrator page. We could do that. We also could literally just try the obvious thing and change the URL to leaderboard. Let's see if we can find it. Oh, it's scoreboard. It's in my history. But I would try a bunch of different URLs like scoreboard, leaderboard, high scores, that kind of thing. But we found it. We found a hidden web page. This is our first hack, is basically finding a hidden web page. And you can see that we have 1% of all hacking challenges complete. And so I am going to focus on all of the challenges that specifically are about cross-site scripting. And so there's a lot of different other types of challenges. Cross-site request forgery, taking advantage of the security policy, bypassing CAPTCHAs, all of these things. Today, we're focusing on cross-site scripting. So let's try to do this first one. It's called DOM XSS. Perform a DOM XSS attack with iframe source JavaScript alert XSS. So this is potentially what we want to inject. Let's try to do it. Now, what I mentioned earlier is there are multiple places that have user provided input, right? There's like this reviews, there's the customer feedback form, but probably the easiest one is just this search box. So I'm literally going to attempt to just throw that in the search box and see if they run it on the page. They do. They're vulnerable. So we have already completed our first cross-site scripting attack. Is literally just inject a script into the page. Via an iframe. And so this isn't something I showed in my overview of cross-site scripting, but basically what they're doing here is it's loading an iframe and then setting the URL to be this. And so this is another potential attack vector. If you didn't know this, any website you go to can... well, not any website, but every web browser supports the feature of having JavaScript : and then some JavaScript code that can be run on a specific website. So if you've ever used bookmarklets, that's actually how these work. Where literally in the web browser, literally in the URL bar, you can just put some JavaScript here, and the page will run it. Let's just try running it on Twitch. So now Twitch has loaded. We try to execute some codes here. It might be preventing it. Does it need an iffy? I don't know. There's a way to do it, though. I might just have the syntax wrong, but you'll notice here, this is literally just doing it with : and then the code that it wants to run. So we found our first cross-site scripting vulnerability. So yeah, awesome. Let's find another one. So if we go back to the scoreboard, I think I tried that, but with a regular function instead of a... Oh, I guess my syntax was still probably a little bit wrong. Okay, good to go. Browsers don't necessarily block it because bookmarklets are still a thing. Are you sure I didn't type the right syntax? And listen, Amaranth hosted was it the creator? She hosted an event a while back. That's why I'm subbed. Or not. That's why I'm following Amaranth. Okay. 100% sure. Okay. JavaScript : and I can follow whoever I want. All right. Come on. Tier 3 supporter. Yeah. Let me just try exactly what Codex has here. Yeah, I don't know what's going on. It could be possible that Twitch is blocking it. I don't want to open my dev tools because it could. I mean, I'm in Firefox. Maybe that's the issue, is it doesn't work in Firefox, but it should work. I just don't have it right. Okay, we got our first one. Let's find the next cross-site scripting vulnerability and try to exploit it. Maybe it's one of my extensions. I don't know. Let's keep going. Oh, we can filter here. So the next one is called bonus payload. Use the bonus payload that in the DOM XSS challenge. Is this going to rickroll me? Oh, no, this is SoundCloud. Okay. I think, like, so this is nothing special. Like, we can basically just, we can just plug this in here, and I think we'll get the challenge. Yeah. And then my privacy badger blocks SoundCloud from rolling, from loading, because they potentially have like trackers and stuff like that. But we could see what music they try to load here. But oh, it's the OWASP Juice Shop jingle. I don't want to play it at risk of copyright strike on YouTube, but cool. So that's awesome. That was another one. That was pretty easy too. All right, another one is a reflected cross-site scripting vulnerability. So perform a reflected attack. This challenge is not available in Docker. Really? Why not? Yeah, I think it's hard to read because you technically can't do it in the Docker one. Let's figure out why that is, and then maybe I'll have to spin it up locally. Or some of the limitations of a Docker container. Maybe I have to do do I have to do all of level 1? It does say this. All of these all say this challenge is not available on Docker. Yeah, we're done. We're done at this point. If using Docker Toolbox, no. Okay. Some challenges can cause potential harm or pose some danger for your computer. These simply cannot be sandboxed in 100% secure way. These are only dangerous if you use actually malicious payloads, so please do not play with payloads you do not fully understand. Furthermore, be aware all stored cross-site scripting vulnerabilities can, by their nature, be abused to perform harmful attacks on unsuspecting visitors. Here we go. We need to disable the safety ride in a YAML configuration file. Or no, we can set this here. Okay. All right. What this is telling me is I can run the Docker container, but with the environment variable unsafe set, and that will allow me to run those attacks. I'm okay with doing this because this is running on my laptop. It's not it's not exposed to the public internet. Any of the payloads that I get that I'm able to inject, I'm not going to try to like delete the files on my machine or anything like that. I'm always going to do things that are fairly safe. So because of those reasons, I am going to enable unsafe features in Docker here. But first, I need to figure out how to set env variables from the command line. Am I sure about that? I mean, I don't know. -E, thanks. Cool. So now when I run the Docker command, I'm going to pass in node env is unsafe. Hopefully that will enable those challenges for me. Configuration unsafe validated. Okay, so at this point, if I refresh the Juice Shop, there we go. We get access to these potentially more dangerous challenges. And what's up, Jarvis? Yeah, I'm still here. I'm still here. Let's go. All right, now we want this reflected XSS one. So perform a reflected attack. And so Reflected means it gets stored somewhere and then you visit a page that has it. So my thought is, can we submit a review for a product, and then when we view that review, potentially this is vulnerable right here. So let's sign up. No, not login. Not yet. This user registration. Actually, here's another potential vector for exploit, which is like my security question. I don't know where my security questions would get listed, but if there's like a super admin page where they can go and see people's security questions, which they probably shouldn't be able to do, but if it existed, this would be an example of stored cross-site scripting. All right. Security question. Mother's maiden name. Garden. All right. We registered. Now let's try to log in. I guess the other thing is we could potentially set our email or our email. I guess they have validation on the email, but we could attempt to do a cross-site scripting injection in the email box too. But now that we're logged in, I want to write a review to do a stored attack. So if I submit this review and then we view the review, it is not vulnerable. Okay. Yeah. What a coincidence. Yeah, isn't it? Okay, so that isn't vulnerable. What about the support chat? Call me that. I can issue a complaint. This is wrong with your site. They specifically give us the payload. So we could reach a point where I can't just put this payload in directly. I'm going to have to encode the character entities or something like that. Customer support will get in touch. Okay. Orders and payment, order history. Recycle. Yeah, we might have to escape the symbols or something like that. Yeah. Here's the thing. My review is here. It's just not getting rendered. So let's go back to the scoreboard, see if it said anything else. Use the bonus payload. Oh, I'm not. Oh, no. No, so this is just the payload. Have I tried all the areas? What if we added to our basket? Do I have to buy it to be able to review it? So a payload, I guess I haven't defined that, but it's basically the potential thing we're trying to inject. So in this case, the payload is just that text right there. But if we were exploiting a command injection vulnerability, the payload would be the actual command that we want to run, which might be something like a reverse shell or something like that. Yeah, we have to send this stuff somewhere. Please provide a mobile number. Address. City. State. Is reflected through search, though? Maybe you're right. Maybe we need to find a page that has query parameters that we can modify. Maybe you're right about that. Also, I don't know how to. The heck's a mobile number? Oh, no spaces. Okay. Great. My address has been saved to the addresses. Okay. I mean, that is reflected. All right. I think I'm going to have to click on the hint here. Yeah, look for a URL parameter where its value appears in the page it is leading to. I see. So, oh no, it does. This is that. Maybe it's because I did this one before doing this one. How do I reset my progress? Yeah, we tried that earlier. Oh, let me just update my command. But yeah, these challenges are here. You can start it locally. Let me update my today command so it'll link there. All right. There was a message from Kaizen, who says, is it considered cross-site scripting if you manage to upload a fake PNG that is actually a PHP script that executes when the first user views it? To me, that almost feels like command injection, but no, I think it would just be, it's a more complicated stored cross-site scripting. So like, instead of storing that info in a database that then gets rendered onto the page, you literally store it in a file that then gets loaded onto the page. But it's still, I would still call it cross-site scripting. Yeah, I think I still would, but it's a different attack vector. So instead of putting it in a database, you're doing it in a file upload, and then it gets exploited like that. So yeah. So I guess this one would be get the payload to run from the URL. Yeah, and that's kind of what we're doing here. Maybe there's some other challenges that need to be completed before this one. Maybe not. All right, I'm going to move on to API only. And if we can get this one working, then we know that there's something just we're missing with that one. And what's up, Bukhari Dev? Welcome in. So the green line at the top means it's completed. So this says perform a persisted cross-site scripting attack without using the front-end application at all. And so this will require us to use something like Insomnia or Postman or curl to make a request to the backend to store some data somewhere. And the way we'll figure this out is by looking at the network traffic. So, I mean, you could use something, I was going to mention that. You could use something like Burp Suite or Charles Proxy. There are tools that work outside the web browser, which will show you requests that are happening on your computer. And then you can pinpoint them to say, oh, that request is happening in the browser for that that specific site that I'm on. But for our use cases, the network tab here with XHR checked is also a way to figure out what requests are coming in, what requests are going in and coming out of the app. And so to me, this feels like if we can get this added via the API, like adding a review here. So what I want to do is I'm looking at the network traffic. I want to see what request is made when I write a review. And if I submit this, we'll notice that it's a put request. So it's doing a put request with this payload. And that's great. You can see my token, which is okay because I'm logged in locally. But we want to basically replicate this request from an API, or sorry, from a HTTP request tool. So let's do that now. I'm just going to start up Insomnia, which is a tool you can use to make HTTP requests from your local machine. There's also things like Postman was a really popular one for a while. You could always, actually, you have a great point, Brilvio. That would make it even easier is if we copy it as curl. I kind of like that. Give me a second though. Let me get these requests set up. But if you didn't know this, in the dev tools inside of your web browser, you can say copy as curl. And so that'll give you a literal curl command you can run from your command line. You could also do copy as fetch, and then you could add that to like your node.js program. We're going to do copy as curl because curl is built into like every Linux machine. That's a big old request. So here's what I'm going to do. I'm going to try to edit the request over here. To only add the stuff that I want. So it's sending it against this URL. It has our user agent. It's passing in our token in the header. It's funny that we have a bunch of other cookies here too, because so I run a lot of stuff locally on localhost 3000. To clear this up, let me actually just clear all of my cookies and everything else. Make sure we only have the stuff that Juice Shop meant for us to have. Because you can see I have like the next auth and stuff like that. Okay. There's probably not anything secure in there. It's all like local dev stuff. Postman accepts a curl. I think Brilvio was saying Insomnia accepts curl too. That's cool. I do want to run it from the command line. But let me log in first. Okay, so now I'm logged in. Now we can only see the cookies that are meant for Juice Shop here. And then if I attempt to add a review, we can see the put here. We'll copy this as curl, and now this should only have the relevant info. There won't be a bunch of like extra headers and stuff like that. Okay. Honestly, I'm guessing that the user agent is how it's detecting if it was sent from the browser or not. So I'm going to set my user agent to HackerMan and then run this to see if that qualifies as doing a API attack. So specifically, they want us to send this payload. So the message is, I guess the issue is this isn't, that we found that box was not, that review box wasn't vulnerable. But still, I'm going to try to run this, and then we'll do the paste into Insomnia to see. But this should just work. So it sent it, and then now if we look at the reviews again, it got it. Like we did something. Error handling, provoke an error that's neither very gracefully nor consistently handled. Honestly, I think what the error was, I set my user agent to something that they didn't expect. Oh, good call. That might have done it too, but these would need to be escaped. Yeah, maybe you're right. But I caused some error. That was a different challenge that I completed. There we go. So now that returned a success. And now if we go back in here to look at the reviews, you can see that that's my most recent attempt to do the cross-site scripting here, which isn't working. We need to find another spot, honestly. I might have to go look at the walkthrough. To figure out why, or figure out potentially where else they might be vulnerable, because we tried the search box. The search box, the name of the user, okay, that's one place we didn't try, Hugo. So let's try that then. You can write whatever you want. That must be the issue then. All right, in the future, careful with your spoilers. Just be like, I think I know what it is. Yeah, no worries, Hugo. I didn't mention it earlier. But I guess I didn't have a. It can't be the email. It would have to be like on the profile page. Oh no! Right here. The author. Good point. You'll notice that when we're using the web UI, it does not give us a place to enter in the username, I guess, if we are logged in. But yeah, when I go to write my review, I can't put my username. But if I'm sending the API request myself, I can put in a username. And so let's see if this does it. Hey, forged review, post a product review as another user or edit any user's existing review. The thing is, that didn't count as the other, that's not the challenge we were going for. We still scored something, but that's not the challenge we were going for. We specifically want to do this one, the API only cross-site scripting. There's a search box on the scoreboard. It'd be fascinating if this was vulnerable. Because it is just the scoreboard. Can I open my profile? It's stripping, the thing is, it's stripping off the first less than, it looks like. Oh, we can, wait, can we set an image URL? What if we did something like this? Or send in an iframe? I'm gonna try this. So like if we imagine that they're injecting it, did I copy it without the opening? Oh, you're totally right. We'll do that in a second. But imagine that they're like rendering, they're replacing the URL directly on the page. This seems like it would do it, right? Because this, if they're not validating this input, because that would close off the previous attribute, set a new attribute. Like this. Invalid URI. Oh, it just wants a URL. Honestly, this might be where we could inject some remote JavaScripts. Yeah, invalid URI. But let's imagine I had a script hosted somewhere. Okay, that's one way to do it. And actually, we're getting a better idea of what's happening here. So not okay. We're gonna hack this. We're gonna hack this box right here. This input box. But I don't know which specific challenge we're doing. there are, yeah, there's some other XSSs in here, but here's what I'm thinking. So because it's setting like the alt tag, oh no, it's setting the username on the profile picture that couldn't load. It's setting that as the alt text. Yeah, you'll notice it's chopping off all of this. Like I'm setting it here, and then it's chopping it off up to the RC. What is it doing? Oh, they have some kind of like replacer, I think. Like iframe space S, they're replacing. Yeah, that's what I'm gonna try right now, Fugas, is if we just do this. I think I tried this earlier though. Okay. First of all, Hugo did give I think a good hint, which was http://JavaScript. Like, would that actually work? Like, this is a valid URI, but it's gonna take us like this. Not quite. Yeah, this is going to take some thinking. It is basically, their backend code is replacing something like starting tag space first letter. See, like it strips that out. Okay. image. It still strips it out. Okay. Here's the thing. I found this random input box here. This would be like, I guess, like client-side, cross-site scripting. Like the on arrow would be the URL. So yeah, we kind of have to figure out how is it actually rendering the page, right? So if we look inside of here, we can see the URL is set to this. And they have a validator on the back end. Honestly, maybe their validator is bad. So what if we did http:// and then we close off the input like this? So if their validator is just looking for starts with HTTP, that's fine. We then close off the double quote and then add our own attribute. Invalid URL. Okay, not quite. Yeah, this is username down here. There already is an onload on the image. Is there? Yeah, this is, I want to do something like this. Like if it, will it validate this? Maybe? What just happened? No, it's the whole thing is the attribute. Because we have source, like, yeah, we weren't able to break out of the attribute of source. This is good though. we at least figured out that their URL validator is only looking at the beginning, it's not looking at the end. Okay. But then the other potential thing we're trying to inject is the but they're not I was overthinking it. The alt tag is already on the image. We should be able to do something like this, like just close off the close off the attribute and then add our own on error attribute. Right? Did I already try this? Let's see what this does. So, reload. Oh, I see. It's not the alt text. It is literally the text that gets rendered below. Yeah. Hugo is mentioning it. The alt text is profile picture. Okay. Well, we've been spending a lot of time on this page. I don't know if this is exactly what we're looking for. Let's pick one of these others and then focus our efforts. Right now, I am just looking at these 3 stars because these are not as hard. What payload is sent when you update the image URL? It would be funny if there's an alt tag in the... Good call. Okay, so, I mean, this is a good hint, but this is another attack vector that I'm not considering is what does the payload look like? And what are we setting it to? But yeah. So if we look at the actual request here, we can see, or can we? It's doing a post. Actually, in this case, it's just a form post with username. Yeah, it's just a form post. So it's just a form post with their username attribute. Okay. Oh, good call. What happens when we link an image? Yeah, so there's multiple requests that happen here. So this is also a form post with image URL. Okay. But like I said, let's try to focus our efforts. I'm gonna look here now. But we're on an ad break, so I'm gonna break for ads for the next 3 minutes, and then we'll focus our efforts. I think I'll maybe try to do this one or the CSP bypass. See if I can figure out, because the reflected and API only, I can't find anywhere else where that might be the case. Maybe I have to do more searching. But yeah, okay. But yeah, quick ad break. For just a few minutes. What other colors can I color a tree? Like a tree would probably have, I mean, it would have like some browns in it, right? We can blend those in. A tree would probably have maybe some yellows. Mm-hmm. Reflected normally means it's stored, so the review was most likely a spot. However, don't want to spoil much, even though I haven't done juicing. Okay, so I think it's. I mean, that's a good hint. That's a much less leading hint. It's just like, look at that user input, the review box. Like, how else can we try to exploit that box rather than just submitting the full iframe text? Because one thing to try probably is like the HTML encoded entities. That might do it. All right. We are back from ads. Let's keep going. I think one spot I'll look at is what Hugo mentioned is maybe there's another injection possible here on the reviews that we're not quite catching. Let's see. Still to this day, Juice Shop will not complete a take you've accurately computed. I see. Complete a task you've accurately computed. I see. In our case, we still haven't gotten these to execute, so I trust that it's not necessarily my issue. All right, it doesn't like the iframe, but it does look. I don't know. This doesn't feel like. Is this? Okay, never mind. It does. I was like, is this text content? It is text content. And then like this is text content as well. I'd be curious if they have some kind of like, I don't know, markdown renderer or markdown parser. We haven't tried with an iframe though. I mean, sorry, with an image. We've only tried with iframe. Okay. I'm guessing this area just isn't vulnerable. I think this is the other thing. Oh, they have a console log just sitting around. This is the other thing is like looking at network traffic for everything we're doing to see like, all right, in this case, like what's getting set here. And like what requests are they making? I don't know. I think reflected should have counted when we put it into the search box like this. I'm curious though, what if I get rid of the progress? I think, isn't it just like cookies that have set the progress? I couldn't find any other pages. Oh, it's in the database? The button to reset isn't here anymore, is it? I want the reset button. Where's the scoreboard reset? Yeah. Yeah, Judge JLo. The one I use is called NPM Upgrade. But I think there are some people here that recommend another one. But yeah, this is an interactive CLI. It'll show you all. You run it. It'll show you what your outdated dependencies are. Checking. Okay, I'll look at my order. Thank you, Nero. That's a good hint. Just like nudge me in the right direction. That's the one I use. I think there's one called Check Updates. npm check. Yeah, here's another one. NCU. Thanks, I'm Fluffo. Yeah, here's another one to check out. They both work fine for in my testing of them. Okay. We haven't submitted an order yet. We'll have to re-log in. Let's make an order. I think that's one thing is we haven't gone through the full. It's really funny. My address is just a bunch of attempts, but we haven't gone through the full order process. All right, so we have a card. We're going to use that one. Place my order and pay. Thank you for your purchase. You can check for status updates on our track orders page. It has a query param. Cool. Okay, so that's a potential attack vector. Should I tweet this? I just purchased apple juice. No, I'm not going to tweet that. Let's try that. This might be the what did they call it? Reflected attack that they were hoping for. No. There we go. I had to load it directly. We did it. At least we got one. We didn't get an alert that. Oh, there we go. Reflected cross-site scraping. Cool. Thank you, Nero. Thanks for the tip. I guess there's like other areas of the application I hadn't explored yet. Nice. Okay. This one is interesting to me. I guess we don't know of a stored cross-site scripting vulnerability yet because the review box isn't vulnerable. I guess technically we haven't figured out our profile yet. Like our profile might actually be vulnerable. We just haven't figured out the right payload. So maybe if we can figure out the right payload and then also do it via curl or insomnia, that might actually count as the no, that was good. Basically, you told me there's more of the application, so that was good. What was I saying? Yeah, so this one here. If we can figure out the right payload, the thing is, I don't even know if this is vulnerable. I think the main thing might actually be the image URL and how it's getting loaded. Because this isn't even the alt tag, right? It's just literally rendering a p tag right inside here. And then we tried injecting attributes, but that's not happening either. And Affinity, thank you for the stretch. We tried, yeah, so that's what we have right now. What are you saying to do? Did Twitch... Oh, like put in a comment? That could be... Possibly. I guess I don't know what they're trying to do with the uploaded image. I think uploading is probably another attack vector, like upload a file that will actually get executed on the server, that kind of thing. But let's try what Hugo is mentioning. Like putting in a... do they strip that out? I think they stripped it out. Okay, I just didn't click submit. It's not breaking out of the the attribute there. I'm curious. I think the book walks us through these. I am going to I'm going to look at the book for client-side XSS. I'm going to see what they say about this. Maybe I can read enough to not get spoilers. Let's see. Bypass a client-side security mechanism. Okay. Perform a persisted attack without using the front end at all. Work with the server-side API directly. A matrix of known data entities and their supported HTTP verbs to the API can help you here. Careless developers might have exposed API methods that the client does not even need. Oh, that's a good hint. Because what if there's like a post request endpoint for updating a product or something like that? I was watching YouTube and it was way more advanced than what we're doing. Okay, so we don't. I guess we haven't done things to figure out like, is there an admin page and stuff like that? Maybe that's the or like a put to, yeah, you're right, to like try to update a product. Right now, that's the only thing I can think of because that's the only thing we have exposed to us. There might be other attack vectors where like we figure out what are all the possible URLs and then we get to an admin page or something like that. Like we don't know about the admin page. Or if there is one. And that would require other hacking things to figure out, or like, and potentially like brute forcing URL searching to figure out what might exist. Honestly, though, I would probably just look, like if this is built with Angular, they probably have a configuration file with URLs. And we'd be able to see that like in the debugger. At least with their code. But let's see if there is, first of all, let's figure out what are the endpoints for products. I'm guessing when the page loads, it makes a GET request to list all products. Let's see. Quantities? Oh yeah, like try /WP admin or something like that. Yeah, it's same thing here. You can see those in your like request logs. Yeah, and we figured that out. Inamuran? We figured out on the product page there was a query param that was vulnerable, so we were able to get that reflected one going. So this returns products. let's just play around in Insomnia and see, do these URLs exist? So like, is there a get products endpoint? There is. There is a get products endpoint. Is there a get products by ID endpoint? And actually, let me just copy this for ease of use. There is. And is there a put endpoint where we can specify the body as JSON and change the name of something? This would be crazy. This would be crazy if I could do this without being authorized. But actually, it's not that crazy because I've found web applications that they just assumed that because they weren't calling these API endpoints from their client side, yeah, nobody's going to find them. Nobody's going to figure out that these endpoints exist. But they do, and they will. Because I think the other aspect of that should be said here is I am manually searching the application, right? Mainly because it's more entertaining to kind of like watch my thought process and see me poke around. There are a lot of automated tools that will attempt to find like every possible input box and just like send bunches and bunches of stuff to every possible input box on a website automatically, like without any user intervention. And so there are tools that make this process that I'm doing even more automated. Yeah, no, that's the exact thing that I ran into, Hugo, is basically a mobile app that was calling endpoints that they didn't think people would be able to see, or they wouldn't see like the network traffic of. Kite Runner will find those hidden endpoints. Cool, I hadn't heard of any tools, so that's one to look into. All right, let's see if this put request will work. Here's hoping. I mean, maybe it won't. Maybe we'll have to find another endpoint. There's an extra single quote, you're right. We're in. We're in. Okay, but that means when we go to the home page, we change the name, but it's not vulnerable. Dang it. We still, this is bad, right? Because here's the other thing. Let's just delete it. Let's delete it from the system. Okay, there we go. So deletion is locked down. Good call, Hugo. Yeah, I shouldn't give up so quickly. There might actually be other. We should try every single field here. Ooh, because like the image, we could try to get the image going too. Description, quantity, we have to try them all. Yeah, you're right. We have to try them all. Maybe the alt tag on these are actually injectable. All right, we're gonna do the description. I mean, I would hope they have a type validator, right? There's no way I can send a string as a number. And then the image URL, I'm gonna go ahead and try and inject this. So I'm gonna try to, like, let's say they set the URL, we'll close it off and then add an on error. That. Ridiculous. Price. You didn't validate that the price was a number. All right. Moment of truth. It's oh, we did it. Oh, we got it. And which part was it? Was it the, yeah, now at this point, I'm not even sure which one was vulnerable. We can inspect it though to figure out. Did my on error work? No, on error is still in an attribute. That didn't escape. This one didn't work. Is it this one? Here's the thing. The scoreboard didn't update. We should have seen like a little surprise. Good call. let's figure out which one actually. Yeah, that's a good way to do it. Which one of these is vulnerable? Description. Yeah, it's description for sure. Oh, because it's literally right. Okay. I'm literally looking at an iframe right now. Yeah, it's getting rendered in the description. Okay. I'm missing JavaScript on the error thingy. Do I want that though? I was trying to bust out of the SRC attribute. I think Google prevents itself from being loaded in an iframe. But yeah, we could literally load any website inside of that iframe that doesn't have that protection. What's up, Project Omega? Welcome in. Set image source as JavaScript. Oh. No. Perform a persisted cross-site scripting attack, bypassing a client-side security mechanism. I feel like what we just did falls under in this bucket. Maybe we're not doing it in the way they expect. What is the danger zone? all of these challenges were disabled initially because they have the potential for real harm on a computer. But I enabled them. Video cross-site scripting. Embed a cross-site scripting payload into our promo video. This one is, it says it's supposed to be really hard. But is it? Will I be able to figure this one out? Where's the promo video about us? There's an FTP upload folder. Okay. I'm going back to the book to see if we can learn anything. Did I not try customer? I thought I did try customer feedback. The issue with customer feedback is there's no way for me to see that feedback. It would have to be like an admin page where they go to look at the feedback and it gets run. But I'm not trying to do any sort of hacks like that. So maybe that's why. Does it appear on the next page? What's 13 minus 4? 9? Thanks so much for your amazing 5-star feedback. Yeah, that's why I don't know of a way to try and exploit that because we can't really even we can't see the feedback. Okay, perform a DOM cross-site scripting attack. Is this one we still haven't? Oh, we already have that one. Let's see what the docs have, or the book has to say about this. There are only some input fields in the Juicebox shop forms that validate their input. Even less, is that CSP? No, this one's the CSP bypass. Okay. Yeah, so only some fields that are validated. Even less of these fields are persisted in a way where their content is shown on another screen. Hmm. This doesn't tell me how to solve it. I thought there were like the challenge. There was like walkthroughs for the challenges or, like solutions. Challenge solutions. Okay. Yeah, we're cheating. We're going to look at the answer guide right now. I guess specifically, I just want to see what do they say about this one, the client side XSS protection. Where will we find that? And then also API only cross-site scripting, because like we found some endpoints, and technically what we were doing here is kind of like API only, but it's not registering. So. Why is the page this color? What is happening? Okay, dark mode's a little easier to read. It's disabled? I mean, I'm not too worried. Refresh did fix it. Thanks, Codex. I didn't try that. Okay. This one. Maybe it did. It didn't. I don't know. I'm not worried about it. It is just the same content. Tell me how to fix. How do I do it? This is interesting. I mean, because we do have to, we'd have to find a like a server rendered page, I think is what they're trying to say. But honestly, I could. The thing is, I could look at the source code. I think like one of the things about like hacking this way is you typically don't have access to the source code. You're kind of flying blind. You only have access to like what's rendered or what API responses you see. And we actually could just go in here and see what are like some old server rendered pages or something like that. This requires in server. Customer reviews show on the about page. You're completely right. Let's try to do that again. Stop the request and modify it. Oh, you can do that with Firefox. Check it out. Or with any browser, really. 2 minus 2 minus 2 is -2. Check it out. So it sent the request to API/feedback. But here in Firefox, if I right click this, I can do edit and resend. And then now I can modify the complete request here. I can change the body, change the headers. I mean, we could try changing the username. No, that's in the same field. The comment embeds the username as well. User ID. Edit a value that's locked on the client side. We'd have to escape this. That was a different challenge. We solved forged feedback. Post some feedback in another user's name. But this also caused a SQLite constraint foreign key constraint. Yeah, it's still not a cross-site scripting vulnerability though. I mean, if we go back to the about us, it doesn't render the stuffs here. Okay. I don't know what to do next. Even the solutions here don't really tell us exactly what to do. Find a screen in the application that looks subtly odd. I'm ruling this one out because if I need to find a screen, do I have to visit every single page? Or I guess we haven't tried submitting a complaint yet. Yeah, I mean, this sets the user ID as well. Internal server error. SQLite constraint. Yeah, the user ID is what causes that SQLite constraint, but that tells me it's probably vulnerable to SQL injection. What's up, Mr. Extremely? I'm just trying to find which. Here's the thing: we exploited this. So there's various challenges here for cross-site scripting, and I feel like we did this one API only, but we're not getting the points for it. Yeah. Update user's username. The thing is, we still are. Oh. Okay, that's actually a great hint, Andy. I didn't even think about this, and I mean, basically at this point, I didn't figure it out. You figured it out. This might actually be a client side replacing, right? Like if we look at the network request that happens, if it's being sent with the replacing, then that means we can fix it, but it's not. See, so the request actually includes the full. They haven't replaced it on the client side. They're sending the full to the backend, and the backend is the one that's doing the fixing. Yeah. But you could be right. Maybe there's an endpoint that doesn't validate. So like if we go to put users, actually, let's see, can we get all the users in the system? Now, unauthorized. Put to users. Unexpected path. Oh yeah, good call. I didn't put an ID on there. And then it says we're unauthorized. We just need to include our token. I guess our cookie. They don't have it in a token. This is our token. And usually it's bearer token. Decoder routines unsupported. Well, it made it past that. And I guess this is making the post request against profile. What if internal server blocked illegal activity? No. Maybe it's because I don't know why that would say illegal activity. It's expecting form data. That's what I was thinking. But the thing is, if we send the form data, it's just going to do the same thing it's doing, like when we're sending it from the client side, because that's illegal. Probably because we don't have a cookie. Like the JSON endpoints want us to have the authorization header, and then like the form the form endpoints have or accept a cookie. Number of redirects hit the maximum amount. Yeah, that's not actually updating it either. Okay, I need to make a plan of what I'm going to do next because I'm kind of spinning wheels. I'm a little bit stuck. I don't know where to go next. Chatbot? Is it vulnerable to cross-site scripting? I guess we hadn't checked that one yet. Support chat. Or oh, I see what you're saying. Is there just a different challenge? Oh, bully the chatbot. We were just trying to focus on cross-site scripting vulnerabilities. That's the main thing. All right. For this one, I think it was Andy that mentioned it earlier, but they might be onto something that there's potentially somewhere. It's this one. There would be somewhere in the app where they validate it client side, but not on the server side. The username field is the server side challenge, meaning if we do it API only, I guess we didn't check. Is there a put request to users 22, API users 22, or a post? Actually, we checked put. We didn't check put. We checked put. We didn't check post. The one at the bottom. Server side XSS protection? This one? Yeah, I think ultimately that one is just figuring out the right payload that isn't going to get caught by their replacer. I'm tempted to just look at how they implement it in their backend code. I'm at this point, I'm already looking for solutions. So yeah, I'm just going to cheat. I'm going to figure out how can we inject into that username property. I'm going to cheat. Big old cheater. So let's find the profile page. This is the rendered page. We want the backend route that handles the post request. Routes. I clicked hint. It doesn't help. It doesn't help at all. Only some input fields validate their input. Even less of these are persisted in a way where the content is shown on another screen. Oh! Okay, I didn't read this hint. The comment field in the customer feedback screen is where you want to put your focus on. I see. Okay. Customer feedback comments. We were messing around with this one. Yeah, we were. The comment actually, okay. All right, I'm gonna stop trying to cheat for a second. I'm gonna stop trying to look at the source code. We'll focus we'll focus on this. Is it API comments or contact? Let's actually look at the network requests that happen here. Test 1. 6 minus 1, 5 times 3, 15. Wrong answer? Oh, order of operations. 6 minus 3 is 3. Regardless, API feedbacks is what we want. Also, this is technically a CAPTCHA bypass. I think. Oh, never mind. Okay. If we do a post request to API feedbacks like this, it accepts it. This is the one we were modifying in the web browser. We were just changing the user ID. I guess we didn't try injecting into the rating. So this is the payload. That's got to be it, right? Rating? Maybe not. What's the 200? Like, what's the valid response that we get? Oh. I've been doxxed. No, that's this is an internal IP address. And actually, if you last week we talked about private and public networks. If you look at the Wikipedia page for private IP addresses, private networks, this one that you're seeing listed here, 172.17.0.1, is within this range here. And that's because this is the IP address of the Docker container. It's a local IP address. Oh, I think who am I? Yeah, it's just an endpoint that returns the current user. I think that's all that is. Okay, let's send this. Hopefully, rating was vulnerable. Let's see. So now, if we go to the about us. Undefined. Are they doing maths on it? Oh, good call. The comment was sanitized. The rating wasn't. You think these are vulnerable? It's not rendering them on the page, though. So the page just has comment and then rating. Oh, well, this is like... You think there's a bypass for comment? Yeah, we'd have to figure out how they're validating the backend. The payload twice? 3 times, 4 times. No, it still strips it out. All right, now I'm going to cheat. Now I can't stop myself. Let's go look at the source code. First of all, I want to look at the this is the feedback page, the feedback route. How is it handling and sanitizing it on the back end? Yeah, that's one type of attack that I haven't tried yet, which is like HTML entity escaping. I guess I'm not completely familiar with how to get that working, because if you use the HTML entities, like ampersand less than, and ampersand greater than, technically, I don't think those actually get rendered on the page. At this point, we've already escaped it. Where's the hip hacker music? I don't usually have music on so that people can put their own music on if they're watching me. See, it gets rendered, you'll notice, but yeah. That's why it's not working, because I don't have hacker music going. Let's see. All right, this is the backend codes that handles the user profile. It's just doing template.replace. This is ridiculous. Don't ever do this. You should use a template in the proper way. I mean, it's literally a pug file. You can render it without doing a replace. Oh. I found the CSP bypass. If you set the profile image to some other domain, that then would allow you to load code from that other domain. That's fun. Okay. I want to find the feedback page. I haven't found that yet. Cheater? Yeah, I told you I'm about to cheat. I'm cheating really bad right now. Maybe it's not in routes. We'll just search their whole repo for feedback. Models, feedback. There's some front end codes, feedback details. Front end feedback service, routes/verify. Is it routes verify? Let's look. Empty user registration. I guess that's another challenge. Oh, these are validating the actual challenges. This is how we find this. That's the solution. Yeah, this is where they compute the challenges. Hmm. Okay. Now, at this point, I'm at a bit of a loss. I've also been live for 4 hours, so I think what I'm going to do is for the sake of YouTube content, I'm going to go back to the Google cross-site scripting game and just solve these. So at least I have some challenges to show in the YouTube video, because I don't. In the past 2 hours, I only did 2. We did the main one, and then we did the reflected one. I can't figure out the others. Hi, YouTube. So yeah, I'm for the sake of content, I'm gonna actually just run through these, and yeah. No, I agree with that, Andy. No, I completely agree with that. Like, here's the thing: Juice Shop is technically written to be vulnerable, right, on purpose. But I would never want to work in a code base that has a single routes folder with all the files just in that routes folder. Right? I mean, I guess we can see, I would hope that their front end is a little more organized. And let me qualify that. Like, as you can see, this becomes like a nightmare to maintain, right? You just, everything's in a single folder. Nothing is separated or categorized by like type. That's usually how I like to see things. Like, I would want to see a folder for auth, a folder for product, a folder for users. Basically group these things by type so they're easier to find and closer together. But that has nothing to do with how secure the code is. That's just like file structure architecture and how easy it is to work in a code base. I would expect their front end is a little nicer because it is Angular, and Angular forces you to be organized. Look at that. Angular forces you to put things into folders of liked things. All right? So, cool. Yeah, that's good. That's good to point out, Mark, is I probably have to solve some of the other challenges before I can do those. All right, we're on an ad break. When we come back from the ad break, I'm going to solve these. I think there's only like 6 or so of these challenges, and then I'll get out of here. But quick ad break. And we'll be back soon. I guess I have a lighter green color too. Oh, nice, Alka. Mostly working on TMI v2. Missing tons of events, but I spent some time getting the build and stuff working. Nice. Is that a public repo? I think you sent me some of the v2 to look at a while back. This is light green. We're gonna color the bushes light green. Nice. You visited the US 2 weeks back. Twitch was barely watchable. Here in Lithuania, you get none. I kind of agree with that. So I had Twitch Turbo for the longest time. And then when they upped the price, I was like, I'm not going to pay for that anymore. But now I might actually do it just because, like, yeah, the ads are insane. Especially the pre-roll ads are the most annoying, right? Because, like, you go to potentially you try to go watch a stream or even a streamer that, like, you've never seen before, and then you immediately get ads. It's a really bad experience. So, like, I feel like it turns off a lot of people from the website entirely, because at that point you're not really even discovering new streamers, right? You click in, you immediately get an ad, and you're like, nope. I mean, at least I am. I skip those channels. It's like, at least I'm trying to pause during ads. The thing is, if somebody showed up right now, they might actually get an ad, because this is not a pre-roll. We've reached the point where we have to serve ads for everyone. But Yeah. I mean, if Twitch looks at their analytics, they would see that. They would see that like people are clicking off of the website the moment they're served ads. Okay. Let's do these. All right, to show some examples of cross-site scripting, we are going to do the challenges on this website. So this website, xss-game.appspot.com, was created by Google in order to teach you about cross-site scripting. And we already did the first challenge, which was basically just putting in some code in the search box, which then gets injected into the page, and you instantly have a cross-site scripting vulnerability. So in this case, if I try to inject an image tag, set the onError attribute to do an alert. This gets added to the URL of the page and then rendered right here. There were no search results for, and then whatever you typed in. And so that actually gets the code to execute. So let's move on to the next level. This one is actually very similar. So users can add their status here. And this is an example of stored cross-site scripting, because when I share this status, it's going to be put into like a database or to the backend, and then whoever visits this page will actually run that code. So there's a slight difference between the previous attack and this one, in that this is stored in a database somewhere, whereas the other one just got injected via the URL in the query parameters. Let's see the next one. So this is loading images. I think the main way to figure out how the page is vulnerable at this point is to look at the source code of the page. And we probably don't even have to look at the back-end code, but if you look at the front-end code, you can see that right here is a little bit of injection. So they're creating a URL, and they're just inserting the number of the image into that URL. And then that's just getting added to the page. So this is our injection point, right? So if we can craft some code that like closes off the src attribute and then adds our own onError attribute, we should be good. We should be good. So let's try it. Yeah, and the URL for whatever reason is messing up. Why is this happening? Yeah, it's showing object. I almost want to load this in Google Chrome, so to see if it works, because we need the URL for this attack. All right. Okay, so yeah, this is what we want to see. For some reason, it's not working in Firefox, so I'm going to do the challenges over here in Chrome. Cool. And then this one, it's a stored attack. Good to go. Now we're on to this one. So the thing to see is that it's actually grabbing the number from the query parameters. So yeah, it's grabbing the query parameter, not the query parameter, the hash from the URL, and then using it as a number. So if we create a carefully crafted injection right here, we should be able to execute some codes. And so, like I said, we basically are trying to inject an onError attribute into this crafted image here. So, or in the crafted image URL. So what I think we can do is close off src. So we do a single quote to close that off. We have our own attribute onError. And then we just add another attribute to make that last one happy. Let's see. Got it. Got it. So basically what we did is that since that code is being turned into the URL, we closed off the src attribute and then added our own attribute. So that was a fun one. All right, what next? So we have a timer. This creates a timer. It takes us to a page, and it says the timer will execute in X amount of minutes. All right. Every time I see var, I wonder how old the code might be. Yeah. And the thing is, some code it has been around a while and still uses var. Yeah, the thing is, if the code's transpiled and their target was older web browsers, it might still have var in it. That's another thing. Okay, so they have a form. When we click create timer, it's sending the timer value, I guess, to the next page. So yeah, it goes here and then timer is some value. Okay. And then the timer page pulls in the timer value into this onload here. So this is essentially trying to, when the image loads, call start timer with the value that they passed in. And then right here, your timer will execute in X seconds. I do believe that their backend code is actually fixing this. It's not going to be injecting any code right there because they're using like a templating engine. So if we look at like the backend Python code, yeah, it's rendering a template, which is going to escape things that get added just like right here. So let's try to exploit it. So this goes to timer equals. And so if we say timer equals, and let's just try loading an image here. You'll notice that it doesn't try to render anything. It actually like puts the content onto the page. And that's because the templating engine that they're using is smart enough to not inject code right here. My guess is maybe we can try injecting on the function invocation. And so if that's similar to the last one, then we can try our best to craft a payload to do this. So I guess, for instance, if we do like single quote parentheses, that will invoke start timer. Hopefully, if this is vulnerable. And actually, we should be able to inspect the page to see if it is using the value directly. Maybe, but our potential goal here is to kind of escape out of this onload attribute. So, single quote, parentheses, semicolon, double quote. That would potentially close this off. And then I would want to add my own attribute. Maybe? Let's just see if I can get an attribute added here. Yeah, there's some other codes here, but I don't think we can change the codes happening here. Can I move that tree? Yeah, honestly, I will, because it keeps getting in the way of the code. Yeah, there we go. Thank you. Thanks for saying that. All right. If we add a double quote, that would be opening a new one. And then we would have alert, pwned, and then the closing single quote. Let's see if this does it. I don't know if it will, but let's see. So the content, it for sure is executing this code. Okay, so if it's actually passing the value into start timer, can I do like an eval or something like that? Yeah. Not even an eval. So if we do start timer, and then right after that, we write our own codes. Let's see. What's up, LQRZ? Welcome in. I'm going to reload this page. I don't know if this... I don't know if it was loading. I feel like it's stripping off all of this. Oh, I see. It's going... I was like, why is this happening? It's going back. It's going back to the previous page, which gets rid of the input that I added there. Yeah, it went back. I was like, what is happening? It's still going back. Okay. But do we need a history.push? Well, look at... Okay, let me inspect the code one more time. But I figure it's not escaping the attribute, so I think that's our attack vector. I think that's how we're going to get some code executed here. This just does window history back. It does a set timeout here, but there's nothing really we can inject there. And then parse int, we couldn't do anything here. Like, I think it has to be this attribute. I just have to figure out the right payload. Let's look at our hints. Take a look at how the start timer function is called. When browsers parse tag attributes, they HTML decode their values first. This is the same as this. Okay. Try entering a single quote and watch the error console. Okay, we've already managed that. But if we do like single quote, semicolon, alert, Won't this get executed here? Missing parenthesis after argument list. All right. I have 10 seconds to figure out what it just did. No, are they sanitizing the input? Because it doesn't have all my extra stuff on it. Can I do a comma? Yes. Okay. The comma did it. Whew. Okay, I'm glad I figured that one out. Pwned. So the comma operator now gave it a sequence of yeah. Let me explain what happened here. We're in. So you'll notice with the payload that I sent, it is actually we're not escaping out of the attribute, but we're executing multiple commands. So this runs start timer, and then I guess I forgot the parentheses here. So if I put the parentheses there, it'll run start timer, and it will run alert. So the comma operator will just run 2 commands back to back, or multiple commands that are separated by the comma. So if I do this, we got it. If we look at their server-side code, I'm curious if they were doing any kind of sanitization, because it was getting rid of the semicolon. Like anytime I had the semicolon in there, the back end was stripping it out, but it looks like it didn't strip out the comma. So next one. All right. We have a page. Thanks for signing up. You will be redirected soon. And then it sets window.location. Okay. And if we sign up, next equals confirm. Then the sign up page sets the href to be next. Okay. Potentially, we could do it on the href here. If we look at their backend code, they render the sign up page. They render confirm. They render welcome. So we could try changing the next attribute here. So next, I mean, let's just try doing a little image tag here. It's just putting it in the URL. It's not actually executing anything. I'd be curious if is the email vulnerable to anything? We're ignoring the email, but the poor user will never know. So there isn't even a form. You click next, and it literally just goes to the next page. All right, we need some hints. The title of this level is a hint. Breaking protocol. Oh, does it have something to do with like the URL? I'd be curious how this gets rendered. Yeah, it's just adding the href right there. The thing is that would involve user interaction, and I think this will work without user interaction. I'm wondering if it is the welcome page. Another hint. It's useful to look at the source of the signup frame to see how the URL parameter is used. It's just, this is like the only place it's added, which is on the href. I guess, are we just trying to break out of the href? I don't know if you can, with the rendering, I don't know if you can close it though. Let's try. So if we just do like single quote, that'll close off href. And then if we do this, we'll try to close off the A and then add our own image tag. So if it gets loaded this way, that will close off the attribute. It doesn't. We can see how it actually gets rendered. Yeah, all of that gets put into the attribute. Or does it? Yeah, it's all in the attribute. Right now, we're not escaping the attribute. I guess we could do like an on click, or can we? Could we do something like this? Like send them to a JavaScript URL? Yes, we can. I guess I don't know if that counts as the vulnerability or it counts as the exploit, because the user had to click that link in order to get it to trigger. But basically, that's really all we're doing here, right? We are setting the URL to execute JavaScript. Cool. Let's see if that's what was the intended one. If you want to make clicking a link execute JavaScript without using the onClick handler, how can you do it? Apparently, that's how you do it with JavaScript colon. All right, we're on to the final level, level 6. Find a way to make the application request an external file which will cause it to execute an alert. Okay. It looks like the URL has a URL in it that it tries to load. Yeah, so it's creating a script. Making sure the script starts with HTTP. And then if it does, it's just setting it on there. So yeah, that's the hack, is if we can get it to load some of our own JavaScript, it'll execute that. Here's what we'll do. Let's spin up a little HTTP server so we can write our own JavaScript. So I'm going to add an alert.js here. And then I'll start up an HTTP server. Like this. And so if I go here, /alert.js, we get this file. So I want to load this file into this page. And then this says it can't have HTTP on it. Do we just remove HTTP? Will it load if I do this? Loading gadget from here. unexpected token less than alert.js. Let's see what happened. Did it make the request? No, so it's trying to do it as a subfolder. Here's the issue. These technically work. If you do :// without a protocol on it, it'll pick the protocol of the page. The issue is, my page is not being loaded over HTTPS. Did I have a filter on? Oh. That didn't work either. So when I do :// it loads from the root. I thought, I don't know if it would be cheating. I feel like I'll have to do that. What if I start the URL with // No, it tries to request it from the server itself, the server that it's there. We need to bust out. How do we bust out? I really did think you could do :// like you don't specify a protocol and then it uses the protocol of the page. Am I wrong about that? Did I remember that wrong? Like, let me just try loading it over here to see if it'll actually load. In my controlled web page. So if I go here, yeah, it's trying to request it from there. Oh, leave off the colon. If you leave off the colon, yeah, that's it. Leave off the colon. Okay, we got it. Because if we leave off the colon, it'll just, but the issue is now it'll try to load it over HTTPS. So honestly, I just need to deploy this. Yeah. Okay, so now here's what we got to do. I'm just going to deploy this example to Vercel. Actually, I think I could even deploy it to Surge. And then that'll give us HTTPS. Does Surge not work anymore? We're in. Okay, so now I have this wonderful website, xssexamples.surge.sh, but it has the alert.js file. Great. But now I can load this file over here. So if I do this, we get rid of the HTTPS. Moment of truth. Pwned. So we got it. So yeah, but that is actually something to know about when you're setting URLs of like script and even like CSS files and stuff like that. If you just do a //, it'll use the current protocol of the web page. And in this case, the protocol of the web page was HTTPS. I don't even need to get rid of the HTTPS, right? Well, you do just because of their validation code. Maybe there's a different bypass, but their validation code is saying if it starts with HTTP, don't allow it. So there could be another bypass where you somehow start the URL without HTTP or HTTPS, but this is the main issue that's preventing it from loading, is they literally are stopping it if it starts with HTTP. But that's also to say, like, the learning here is you shouldn't use such a simple regular expression to validate a URL. You should use like a known, tested, good URL validator, because there are other things to consider other than just does it start with HTTP. You want to validate, like, is it a valid URI? But yeah, it's not using HTTP, but it's basically the browser is inferring the protocol and loading it automatically. So you'll see here, because I just did // the browser infers HTTPS, and then loads it in. Cool. We did it. We did it. So yeah. Oh, did I not show the hints? Let's show the hints thing. So see how the value of the location fragment influences the URL of a loaded script. Is the security check on the gadget URL really foolproof? Sometimes when I'm frustrated, I feel like, wait, what? If you can't easily host your own evil JavaScript file, see if google.com/that will help you here. Oh, that's another thing. I don't even need the //. Maybe I do. Yeah, because if I don't have the // it requests it as a path of the current website. I don't know if my solution is the only solution, but we did at least get it to execute remote JavaScript. Cool. Let me try to do some kind of like summary for the YouTube video. Yeah. It won't work. It won't work because it has the client side code here that says, hey, you can't do that. Yeah, no worries. Also, you can try it yourself. Go to this website. You can try all of the challenges that I just did. Yeah, I don't know if we could have hosted it like on FTP or something like that. That would have been a different protocol. But yeah. Okay, that's it. That's all. Thanks for watching this. Ultimately, I think I want you to walk away with, first of all, knowing that XSS is a thing, because knowing is half the battle. And then now that you know about it, make sure that the applications that you build are not vulnerable to it, and at least try to check and see if they are vulnerable. Yeah, what else do I want to say? I mentioned some things that you should avoid doing if you're working in a front-end framework, because these are really the main areas where you're going to expose yourself to cross-site scripting if you're working in a front-end framework. So ultimately, if you do need to use dangerously set inner HTML or VHTML or add HTML, make sure you're at least sanitizing the user input with a library like DOM Purify. And the ultimate takeaway here is always sanitize user-provided input. You can't trust any user at all. And you should always sanitize any input you got from a user that you're potentially adding to a web page. So thanks for watching this video. We'll see you in the next one. Cool. That's it. That's all. I'm going to get out of here. Thanks for tuning in, everyone. Be sure to tune in on Friday. I will be live for Try-Day Friday. So if you take a look at the schedule, the plan is to learn Laravel and PHP. I've done some basic PHP in my life, but I have not worked with the Laravel before. So I want to be from the ground up learning about Laravel and PHP on Friday. And yeah, Nero, thank you for tuning in, Nero. I appreciate the tips that you and hints that you gave us earlier. But I think ultimately I think the main issue with Juice Shop was I did not there were potentially challenges I needed to complete before I could do the other challenges. But yeah. So yeah, tune in on Friday. I'd love to see you here. And in the meantime, if you're not following on if you're not following on or subbed on YouTube, go sub on YouTube. If you're not following on Twitch, and you're watching on YouTube, check out my Twitch. And I also have a mailing list. So if you want to get go live notifications and also weekly updates, which I haven't sent in a while, but eventually I will, you can sign up for the mailing list. We also have a Discord that you can join. And that's it. Let's go on a raid. Here are your raid messages. If you are a sub, you can use that raid message. And if you're not a sub, you can use this raid message. You can also come up with your own raid message. And if you're watching over on YouTube, you can head over to Twitch to join us in the raid. Literally just click the link, and in about 2 to 3 minutes, you'll be taken with us to someone else's stream. Cool. This was fun. Thanks again for watching on Web Security Wednesday. We'll see you on Friday for Try-Day Friday. And wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.